How many times have you finally wrapped your head around Next.js, only for them to drop another version that renames half the features, breaks the other half, and promises to simplify everything? Yeah, same, every single time. But this time, it's actually worth it. Or is it really? Hi there, and welcome to the Next.js Crash Course, where I'll teach you not just the why and the what behind Next.js, but also dive straight into how to build real projects with it. First, you'll go through a deep crash course to visualize and master essential Next.js concepts, like architecture, rendering, routing, caching, adapters, API, and its powerful full-stack capabilities. Then, you'll dive into the code, bringing those ideas to life as you build a real-world application designed to teach you how to use these features the way the top companies do. This crash course alone will give you a rock-solid foundation. But if you're serious about mastering Next.js and taking your skills to a professional level, I've got something special for you. The Ultimate Next.js course. Right now, the most popular Next.js course on the internet, where we go beyond the basics and dive deep into advanced enterprise-grade features. And I just launched the complete Next.js testing course too. So if you're watching this video right now, you can still grab our launch week bundle at 33% off. This is not a drill. I repeat, this is not a drill. You're getting two massive courses, the brand new testing course and the Ultimate Next.js 16 course, plus a tactical testing ebook, all bundled together. This deal will disappear forever and the price shoots back up. The link is in the description, but honestly, pause the video right now and go grab it, because the last time we did this, the early birds cleaned it up in about 6 hours. But if you're still wondering whether Next.js is really worth learning, well, just ask Netflix, TikTok, Twitch, Hulu, Nike, Notion, or even OpenAI. The Next.js hype is real, even though it changes often. And if you don't dive in now, you could be missing out on career-changing opportunities. So yeah, it's the perfect time to impress employers and build your portfolio with something that screams production ready. Here's what you'll build and learn inside this video. File-based routing to master the core structure that makes Next.js lightning fast. UI development, where you're going to design and develop beautiful responsive interfaces that scale effortlessly. Client and server components, where you'll finally understand when, where, and why to use each one. Database modeling with MongoDB, where you'll structure your data the right way from the start. API routes, where you're going to build robust backends without leaving your Next.js project. Also server actions, image upload and hosting with Cloudinary for proper asset management, use cache, the hot topic of Next.js 16, SEO that works well, analytics powered by PostHog, an open source platform that gives you product insights, web analytics, feature flags, A/B testing, and session replays all in one place. And all these by ensuring you write production-level code with the help of CodeRabbit's intelligent roasting code reviews and AI-assisted development using Warp, where you'll be the architect and AI will do things for you, perfectly mirroring real-world industry workflows. So once again, everything you need is hiding in the description, like that bug you've been looking for. Free video kit containing the codebase, Figma designs, the Next.js guide, plus the testing course bundle that's 33% off until it self-destructs in a couple of days. Seriously, check it out. I know you never read descriptions, but this time, it's worth it. Time to cook. Let's go. Let me start with a very important first question. What does Next.js have that React doesn't? In simple terms, Next.js simplifies the development process and optimizes your applications. It does that through its primary functionalities, some of which you have to actively decide to use, and others that you get out of the box just by switching to Next.js. The first of Next.js's benefits is its architecture. Originally, React had two types of components, functional and class-based components. But now, components are also categorized by where they run. If a component runs in the user's browser, it's called a client component. And if it runs on the server, it's called a server component. This division was released in React 19, and although frameworks like Remix and Astro also support it, Next.js was the first to adopt it and fully utilize it. Since server components are more performant, Next.js automatically converts every new component you create into a server component, unless you specifically instruct it not to, only if you need some browser functionalities, but more on that later. The second Next.js benefit is in the way it handles rendering. While React 19 supports server components, Next.js extends them to more advanced rendering strategies, allowing you to choose exactly where and when they'll be rendered, optimizing the performance even further. First is client-side rendering, which happens on your browser. The server sends a basic HTML document and JavaScript code, which the browser executes to render the components and display the website. And the second is server-side rendering, which involves rendering the web page on the server before transmitting it to your browser. When you visit a page, the server processes and renders the components on the server and sends back fully rendered HTML and JavaScript code to the client, instantly displaying the website. But why does this matter? Well, on top of the fact that your website will load in 300 milliseconds and have page speed insights that look like this, server-side rendering will significantly improve your website's search engine optimization. Client-side rendering makes it almost impossible for search engines to crawl and index your websites, as they're completely empty. Next.js solves this issue by sending pre-rendered code, giving Google plenty of stuff to rank us on. The next big Next.js benefit is, of course, routing. In React, you need to install an additional React router package to create routes. On the other hand, Next.js doesn't require installing a separate routing package and uses a much more intuitive approach to routing called file-based routing. Each folder's name becomes a route's path. For example, a folder named About will create a new /about route. Super simple, right? And connecting directly to the routing system, the next best thing about Next.js is its evolution from a simple front-end library to a full-stack framework. Using the same file-based routing system I just described, you can also create serverless functions to handle native backend API requests. This means you can create an API endpoint by simply creating a file called route.js in a specific folder without needing to worry about the server infrastructure. Next.js takes care of scaling automatically. And there are many other scaling features that Next.js provides out of the box, like automatic code splitting. While code splitting in React is possible, it requires manual configuration, especially as the application grows. Next.js automates code splitting by default. Well, what does that mean? It means that when a user navigates to a different page, only the code for that page is loaded, which significantly speeds up page load times. Pretty handy, right? But that was just one out of many built-in performance optimizations that Next.js provides. Font optimization reduces layout shift, improves loading time by preloading font files, and reduces reliance on external services like Google Fonts. Image optimization automatically compresses images and applies lazy loading, CDN support, and more. Script optimization optimizes even third-party scripts. And all of these great optimizations come right out of the box with Next.js. And it's not just performance. Next.js is the definition of cutting edge. It supports the latest features such as React Compiler, MDX file integration, managing most SEO-related tags, analytics that run without blocking UI, fast refresh, server components, hot module replacement, and more. Oh, I know that was a lot, right? That's totally okay. Stay with me and I'll teach you everything I know about Next.js in this crash course. Let's dive right into the demo and start using the React framework for the web, used by some of the world's largest companies, enabling you to create high-quality web applications. You can either click Get Started or just copy this installation command. Now, throughout the demo, you'll see me use WebStorm, a super powerful JavaScript and TypeScript IDE that, as of recently, became completely free for non-commercial use, which means that us regular developers can finally get the benefits of having a powerful IDE and not just use a regular text editor. So feel free to download it. The link is down in the description. And another thing that makes working with WebStorm a breeze is Junie, a smart coding agent. You can also download it, as you'll see me use it across this project, and it just improves your productivity so much more. Like, you can ask it questions or you can ask it to do things for you. Throughout the course, I'll show you more of what it can do. So once that is done, we're ready to start from the bare basics by creating a new empty project. WebStorm allows you to immediately start with a Next.js generator, which will install the latest version of Next.js for you. In this case, just so we can all follow along together, I'll start with creating a new project and I'll call it Next.js Demo. And we'll do it using TypeScript and click Create. Immediately, we'll be right within this project. So open up your terminal and paste the command you copied over from Next.js. That is npx create-next-app add latest, and then add the // to generate it in the current folder. But for now, I'll just delete this source folder and the additional files that got created for me by WebStorm, just so we have a completely clean slate. Once you press enter, you might need to install the installer, but once you do, you'll be asked a question. Would you like to use the recommended Next.js defaults? See, the installation process for the new version of Next.js got streamlined. You can still customize your settings. Like if you choose this option, you'll be given like 10 more questions to choose exactly how you want to architect your project. But in this case, the recommended settings are exactly what we need. TypeScript, ESLint, Tailwind CSS, App Router, and TurboPack. So go ahead and select the first option, and that's it. Next.js just started installing the dependencies, and there are just a few of them. React and React DOM and Next.js, that's it. When it comes to dev dependencies, there's also TypeScript, all the different types, as well as Tailwind CSS and ESLint. And in a couple of seconds, your project code is right here. Before we go ahead and run it, there's a new feature in Next.js 16 called TurboPack file system caching, which allows for significantly faster compile times across restarts. All internal Vercel apps are already using this feature. So if you'd like to enable it for your project, head over to Next.config, and then right at the top, you can say experimental and turn on the TurboPack file system cache for dev and set it to true. TurboPack is an actual word. Looks like WebStorm doesn't know about it, so I will save it to the dictionary. Now let's talk about the project structure. Your project is set up and ready to go. You'll see many files and folders, so let me walk you through them from bottom to the top. Starting with tsconfig.json. This is the configuration file for TypeScript. It defines what should be type checked, ignored, and which rules to follow. After that, we have a readme.md, which is a simple markdown file that explains how to run the project and provides all other relevant information. Then there's the post.css config.mjs, which is a configuration file for post.css, which is a tool used to process CSS with different plugins. You can see here that it mentions Tailwind CSS as a plugin, which allows you to use its utility-first classes within your project. Then there's the package lock.json. It's a file that locks the versions of dependencies and their exact subdependencies, ensuring that everyone working on the project uses the same exact versions. Then there's the package.json, which contains all the project dependencies and scripts. You can see that the name of the project is Next.js demo, its version, right now it's set to private. Then we have the scripts such as npm run dev, which will run the application in development mode, build to run an optimized production build, and there's also start and the lint. Package.json also keeps track of other dependencies and dev dependencies, which are only ran when we're developing. After that, we have the next.env.dts. This file should not be touched. It's simply used as a Next.js TypeScript configuration. And then a super important file is next.config.ts, which allows you to configure your Next.js features, such as experimental options. You can see that there are many that you can actually use here, image settings, build settings, and more. There's the ESLint config, which allows you to configure ESLint for linting, .getignore, which allows you to ignore some files not to be pushed over to GitHub. And then we have two folders. The public folder, which is a place for static assets. You always need to put your images and other static data right here. There's also a node modules folder here, but I've hidden it because I never actually have to go into it. It's the heaviest object in the universe, you know? Well, jokes aside, it's a folder containing all the dependencies and packages that are required for your application to run. And finally, there's the app folder, which we'll explore next. You'll primarily work within this folder on most feature implementations, including creating pages, layouts, API routes, and more. So before we dive into the details of the files within here, let's actually run our application by opening up our terminal and running npm run dev. This will spin it up on localhost 3000, and if you open it up, it'll look something like this. To get started, edit the page.tsx file. Okay, let's find where that page.tsx is. Looks like it is here. This file represents the homepage or the / route of your page. It contains some boilerplate code by default, so let's remove it entirely. Run RAFCE, which is a super nice snippet that I often use to create a simple React arrow functional export component. So press enter, and we can call it home. If this snippet didn't work for you, you must head over to plugins or packages, and then search for React snippets. Any package should do. In this case, I'm using modern React snippets. Here, we can say something along the lines of, welcome to Next.js. No longer in modern versions of Next.js is it needed to import React. It is done by default, so the view is even simpler. Let's explore other files right here. There's the favicon.ico at the top. Any file with this name in the root of the app will become your website's favicon. It's just a naming convention that allows you to add that little image that shows next to your title within the browser tab. There's the globals.css, which is where you can write all your custom CSS or Tailwind CSS utilities. Then there's the layout.tsx. This is the main entry point for your application. So anything that you do here will be applied across all pages and routes. That's why here we're importing and setting different fonts, as well as the application metadata. For example, if you change the metadata from create next app to welcome to Next.js, you can also change the description to something like check out jsmastery.com for more. Oh, and this is definitely not true. JS Mastery is a real word, so I'll add it to the dictionary. That's much better. So now if you head back to the browser, you'll see that the title changed, and you can also see welcome to Next.js. If you go ahead and change some class names, like making the text extra large, like saying 5XL, or making it underline, as soon as you get back to the browser, you'll be able to see changes instantly, thanks to Next.js's hot module replacement. So now that you're familiar with the entire Next.js application structure, in our next lesson, we'll get our hands dirty. At the start of the crash course, we talked about architecture, where we can write two types of components, client and server components. If you remember, I said that by default, the React components you'll write are server components. But are they really? If I head over to page.tsx, where we have our homepage component, let's add a console log before running this return. I'll say console.log, and I'll say what type of a component am I? Sounds like it has an existential crisis right here. But don't we all when new versions of Next.js drop? Now tell me, where do you think this console log will show up? In the browser? I was about to say no, it won't appear in the browser because it's a server component, but in recent versions of Next.js, they actually extended that server console log so that it appears in your browser's console as well. But don't let this confuse you. This console log is not happening within the browser. Next.js is just sharing it here with us for convenience. Server components are rendered on the server. So this brings me to the topic of React server components. They're the components that are rendered on the server, and their HTML output is then sent to the client. Since they're rendered on the server, they can access server-side resources directly, like databases or the file system. This helps reduce the amount of JavaScript sent to the client, improving performance. Server components are excellent when you need direct access to server-side resources, like accessing files in a file system, or you want to keep sensitive information, well, sensitive, such as access tokens and other keys, safe on the server. Alright, but if server components really are better, why can't everything be a server component? Well, if your component requires browser interactivity, such as clicking buttons, navigating to different pages, and submitting forms, then you need to turn it into a client component. So what are React client components? Client components are, of course, rendered on the client side. And in this case, client side simply means the browser. To use them in Next.js, you must add a useClient directive at the top of the component. So back within our demo, let's create a new component. We can do it within a new folder called components, and then within the components folder, create a new file called hello.tsx. Within here, I'll create a new React functional component like this, and it doesn't differ from the previous server rendered one, all until one point, when we give it a use client directive. This line right here will make sure that this entire component is client-side rendered. So if we give it a console log and say something like, I am a client component, and now we import it into our homepage by heading over to page.tsx, and we render it right here below this div. But first, I'll wrap both of them within a main tag, and then I will render the self-closing hello component, which we're importing from app components hello. Now, back within the browser, we still see this server log, which is fine. And of course, there is the I am a client component console log, which makes sense because we're rendering this client component, well, on the client, the browser. But to verify, let's quickly check out the terminal. Oh, and what is this? The log of the client component is also here. But how? Or more importantly, why? It's making me question myself now. Well, there is an explanation. Well, this is because server components are rendered only on the server side, while client components are pre-rendered on the server side to create a static shell and then hydrated on the client side. This means that everything within the client component that doesn't require interactivity or isn't dependent on the browser is still rendered on the server. The code or parts that rely on the browser or require interactivity are left as placeholders during server-side pre-rendering. When they reach the client, the browser then renders the client components and fills in the placeholders left by the server. I hope that makes sense. And that answers the question of what is server-side pre-rendering. A pretty cool feature by Next.js. I hope that's clear now. But if you're still unsure, take a second to pause it and re-watch it until it clicks. You can also add some additional console logs or components and then render them within the page.tsx. Don't proceed further if that doesn't make sense. And for a deeper dive with clearer explanations and more visuals, I would recommend checking out the Ultimate Next.js course, where I break down the entire client-server architecture in detail. So finally, when should you allow Next.js to turn your components into server-side components, and when should you manually change them to client-side? Well, a good rule of thumb is to leave it as server-side component until you need some browser interactivity, at which point you'll most likely get an error, and then you can add the use client directive at the top. Now that you understand the React components and how they work in Next.js, there's an important update in Next 16. React compiler support is now built in and stable. It automatically memoizes components to reduce unnecessary re-renders. No more of those use memo and use callback hooks. The compiler analyzes your code at build time and optimizes rendering behavior automatically. To enable it, we have to install the plugin. So open up your terminal, and I'll actually keep this one for my application running, and then I'll open up another one, which I'll call terminal, within which you can run npm install Babel plugin React compiler at latest. Once it installs, we can head back over to our nextconfig.ts, and at the top, we can set the React compiler to true. That's it. Now it's time to explore routing in detail, because doing everything in a single page is boring, right? Like right now, we only have a homepage. But what about adding an additional page like /about? Well, Next.js uses file-based routing, which means that all the pages and layouts can be right here within the app folder. Oh, and therefore it's important to mention the components folder contains components and not pages, which means that it needs to be outside of the app folder. Then within the app, create a new folder and call it about. Within about, you can create a new page called page.tsx. And in there, you can render a simple component that simply renders an h1 that says about. Now, if you head back over to your application and modify your URL to /about, you can see that you'll instantly be redirected to the about route. It's being displayed in the UI. That's how you create routes in Next.js, as opposed to a very boilerplate-ish way to do it in React using React Router. In Next.js, we use a file-based routing system where folders are used to define routes. The folder name becomes the route name, and the page.tsx renders the UI for that route. It's like a special file for displaying the route's content. But that's not enough. Let's say you're developing an admin dashboard within this application, and you want to create a route, something like /dashboard/users and /dashboard/analytics. These are two different pages. Of course, you can't create two folders with the same name, right? This is where we use nested routes. So let me show you how we would do this. Simply create a new folder called dashboard, inside of which we'll create two more folders, one named users and the other named analytics. Both of these folders will contain their special page.tsx, within which I'll simply run rafce. I'll rename this one to analytics, and then within users, I'll also create a page.tsx, and I'll call this one users. Now, if you visit both of these routes by heading over to dashboard and then users, you'll be able to see users. And if you head over to dashboard/analytics, you'll be able to see analytics. Perfect. That's exactly what we wanted. Still, this may not be enough. Because what if you want to display each user's profile in the dashboard? Let's say that we have 4 predefined users in dashboard users. So right here, I'll call it dashboard users. That can be within an H1. And then right below it, we'll have a UL, an unordered list, with a class name of margin top of 10. And then within it, I'll create an LI with users from 1 to 4, like this. Now, let's say that you want to make each one of these list items clickable, so that when you click on user 1, you want to show full user details on a new page, like dashboard users user 1, and so on. You can't create these folders manually right here within users, like user 1, user 2, user 3. I mean, you could, but you would not be going anywhere. Because the next day, there's going to come a user 5, 6, or 10,000, and your life can't simply turn into creating folders. I think you have a bigger purpose than that. So this is what dynamic routing is all about. It's a route where part of the URL can change or be dynamic, typically based on the user input or specific data. And creating a dynamic route in Next.js is simple. All you have to do is wrap the changing part in square brackets. In our case, it'll be /dashboard/users, and within users, I'll create another folder that'll start and end with square brackets, and within it, I'll say ID. Then within this weird named folder, I'll add a new page.tsx. Now we'll modify the general users page to make each one of these LIs a link. I'll do that by selecting multiple cursors and render a link component coming from next link. So make sure to import it at the top. Then to each one of these links, I'll give an href of /dashboard/users/ and then their number, like 1, 2, 3, and 4. We can now close this link and then add the user text within it. That'll look something like this. Now, before we test these links out, if you now head over into this ID page and run rafce and call this user details, and then you head back over to your /dashboard/users page, if you try to click on some of these links, you'll automatically be redirected to the user details page. 1, 2, 3, 4. But each one of these just renders the text of user details. It's nothing specific. So how should we know which user's details should we actually render? Well, exactly for that purpose, there's a concept of params. See this part within square brackets, the ID? Whatever it says right here gets populated within params. So these structure the params, and we can define their type. Params are actually a promise which gets resolved in an ID, which will be of a type string, which means that we can now extract the ID from params. But since it's a promise, we have to await it, which means that we need to turn this entire function into an asynchronous function. Yep, that's valid. These are called page params, and you can get these through the Next.js page only. If you want to get this info somewhere else, you either have to pass it down through a component or use a hook called useParams. So what you can do now is modify the text right here to render an H1 and say showing details for user number, and then we can render the ID because the ID is actually either 1, 2, 3, or 4. So if you head back and now switch over to a couple of users, you can see that each one of these page will be a new dynamic user. Right now, we're just rendering their number, but I think you can imagine that later on, we can show entirely different profile pages, user details, and maybe the posts they generated on this platform. So now you know how the file-based routing in Next.js works, how we can do nested routes, as well as dynamic routes through page params. Great work. Next, let's talk about layouts. Earlier, I briefly went through the main layout file, this one right here in the app. And I call this the starting point of our application. To demonstrate that in the concept of routing, if you go back to that file, and then right here at the top of the body, you add some piece of text like coming from the main layout. And if you go back to your main route, which is the homepage, you'll see coming from the main layout, then the text right here, and then hello. But if you switch over to localhost 3000/about, you'll also see the text that says coming from the main layout. And this will happen for every other page, including dashboard analytics or dashboard users. Yep, it's here too. This is because layout TSX acts as the parent for all of these routes. It allows you to share UI elements, like this piece of text right here, across multiple routes. For example, you can place features like a navbar or a footer right here. Let me give you an example. I'll say navbar right here, and then below the children, I'll render the footer. So now if you go back, you can see that it appears across all of these different pages, on the home page, on the about page, and even on the analytics users page. Simply add them once within the layout, and they'll be available whenever needed. In Next.js, a root layout like this one is always required. But you can create additional layouts if necessary. Let's say you want to render a specific UI just for the dashboard routes. These two right here. You can do that by creating another layout inside of the dashboard folder. I'll call it the same, layout.tsx. Don't try to call it something else because otherwise Next.js won't recognize it. Now, within it, you can create another React functional component because a layout technically isn't anything else than just a component, but it works on the principle of using props of children. Children is nothing else than a prop that is of a type React node. So basically, it's another component that we can pass within this layout for it to get rendered. So if you wanted every single component in the dashboard to have like a special dashboard navbar, you could create a p tag here that says dashboard navbar, and then render the rest of the children, which is basically the full pages that you're trying to render. If you now visit the user's dashboard, you'll see both the regular navbar coming from the original layout, as well as the dashboard navbar coming from the second layout. Hopefully that makes sense, right? But wait, what if you don't want the root layout to appear in the dashboard routes and only be shown in non-dashboard routes like the homepage? This means that you need a separate navbar for the dashboard and another one for the non-dashboard routes, which is very similar to how things work in real life, right? In such scenarios, you can use route groups. They allow you to organize your route segments and project structure without impacting the URL path. This means you can create folders, but unlike nested routes, these won't show up in the URL. How to do that is by simply wrapping the folder name inside parentheses. In our case, let's create two folders with two names. The first one will be right here within the app, and I'll call it dashboard, but this time wrapped in parentheses. It'll be for all the dashboard related routes. And then I'll create another folder within the app, and I'll call it root, also in parentheses, for other non-dashboard routes. And move the page.tsx as well as the about folder within the root folder. Now, remove this navbar and footer from the original layout. This is the primary layout. And instead, create a new layout within the root directory. It'll be called layout.tsx. You can run rafce. As you know, you're going to get access to the children. So we can even duplicate the layout that we have within the dashboard and simply paste it right here. This time, I'll give it just the navbar. So now we have the root. Within it, you have some folder of about, and then you have another layout and page. Also, move this layout from the dashboard without parentheses into the outside dashboard folder. So now both of these route groups, so-called, have their own layouts. So with all of those changes, let's check how everything is working now. If you head over to the homepage, you'll see that here we have the general navbar. If you head over to About, there's also the general layout navbar. But now, if you head over to localhost 3000 /dashboard/analytics, for example, here you'll see that we have a dashboard navbar. And this one is also shared within dashboard users. Perfect. So why are we using these route groups in the first place? Well, route groups allow you to create folders without affecting the URL. See, you don't have to go to root about or root page. This is not taken into account when you go to the URL bar. Rather, it is still just home or / for the home and about for the about. And then you don't have to do the dashboard analytics. Rather, it is just dashboard analytics because this is not a route group, but this one is. So even though creating route groups isn't taken into account when forming URLs, it still allows you to add layouts inside of them. And keep in mind that there has to be only one single primary homepage. Since route groups aren't taken into consideration when forming URLs, if you create a new page.tsx within dashboard here, and you already have one within root, that would not work because these two files would fight on which one would prevail. So let me give you an example right now. If I create a new page.tsx within the dashboard and create a new component within it, you'll get an error saying that you cannot have two parallel pages that resolve to the same path. Check out dashboard and root. So I'll go ahead and delete this one. And from Next.js 16 onward, routing and navigation have been completely reworked, making transitions much faster. The biggest update is layout deduplication. When prefetching multiple URLs that share the same layout, the layout is downloaded only once instead of per link. This optimization will happen automatically with no code changes required. That's what I like to see. Let's talk about error handling. In Next.js, there's a special file called error.js, or TS if you're using TypeScript, that catches errors and displays them on the UI. Similar to how we were able to create multiple layout files for each folder, be that a route group or a route folder, we can do the same for the error.ts file. Let's throw an error on purpose within the about page. So head over to root, about, page.tsx, and right at the top of the page, I'll say throw new error, and let's say that this feature is not yet implemented, like this. Now, if you visit the about page, you'll see what most developers don't like to see, a huge error pop-up that breaks our entire application. Instead of this, what would have been much nicer would be to see this error nicely packaged within a nice UI. To fix this, we can create a special error.tsx file in the root folder. So let's do it right here. And I'll call it error.tsx. And apparently, this error file has to be a client component. So we have to add a use client directive. Do you know why? Well, it's because these errors happen on the client or user side. So if we want to show them there, it has to be a client component. Now, if you check out the error handling documentation, you'll see an example of a simple client error. Just search for error.tsx. I'll go ahead and copy it and then paste it right here. It'll look something like this. It says error boundaries must be client components. We import useEffect for side effects. We get the error and the reset coming from props. We console log the error within the useEffect whenever the error changes. And then we display a message saying something went wrong, and then maybe a button that helps us reset it. So if you revisit the About page now, even though there's going to be a warning that you can open up right here, you'll be able to see something went wrong and then try again buttons right on this page as well. So you can more easily explain to the user what really happened. If you just want to have one global error, then you can do it by creating a global error.tsx file in the root of the app folder. Unlike layout.tsx, which displays everything from its parent, the error file works differently. Only the closest error file to the route takes priority, meaning you won't see the content both from global error.tsx and from the root error.tsx. Errors will bubble up to the nearest parent error file. Not all of them. Make sense? And to talk about something else other than errors, let's talk about loading UIs. Loading UIs in Next.js works very similarly to error handling. You want to show some kind of a loading progress while data is being fetched for users with a slow internet connection. It's as simple as adding a new loader.tsx file within the app. And within it, you can add some kind of a loader or spinner component. While the data is loading, Next.js will show the content you specified in the loading file. And once the data is received, the content in the page you're trying to render will be shown. It's super useful and surprisingly easy to do. I've covered this in more detail in the Ultimate Next.js course. As you can see here, there's an entire section dedicated to it, complete with challenges to help you practice. But in this crash course, you'll also see this in action in the next segment, where we'll actually do some real-world data fetching. Next.js 16 also introduces forbidden and unauthorized special files. They work similar to loading. You can use them to show a nice UI asking user to sign in, or tell them that they have no permission to view the page, instead of simply showing an error or redirecting them. You can explore all of these within the Next.js docs, or within the Ultimate Next.js course if you want to go deep. Data fetching, the most interesting concept in Next.js. There are different ways in which we can fetch content. A traditional way is using a useEffect. For example, this is what you would do. Let's say that you have a homepage where you're trying to set and fetch some albums. You create a new empty use state. You declare a useEffect within which you declare an asynchronous fetching function. Within it, you have an await fetch where you're trying to get some albums, and then you return that JSON and set it to the state. Finally, going a bit down, you map over those albums and show the data. But this isn't super efficient. There is a better alternative to fetch, and it's happening on the server side. Not only is it faster and more efficient, the code is also so much cleaner. Check this out. You declare a new functional component called home, and immediately on top of it, you make a fetch request. You check if it fails. If it doesn't, you simply declare it and set its response.json to the albums variable. You map over it and display the details. Go ahead, pause this video and test it out. You don't necessarily have to do all the styles, but you can at least try to fetch the data, map over the albums, and show each album's title. If you do it, visit the website and see if it works. You'll not see anything. You'll have to refresh to see the result. And it's not because HMR is not working, but rather HMR is caching your content. In latest versions of Next.js, there is a new feature called Server Components HMR Cache that allows you to cache fetch responses in server components across hot module replacement refreshes in local development. What this means is you'll have faster responses and reduced costs for build API calls. But now, coming back to the difference between server-side fetching versus client-side fetching, first of all, you'll notice the code difference between the two strategies. With server-side fetching, you wrote fewer lines of code, which improves the DX, developer experience. But that's not the only benefit. Server-side fetching has so many more benefits, like improved initial load time. As a server-side data fetching allows the page to be rendered with the data already included, it reduces the time to first contentful paint, FCP. In the client-side example, the user sees an empty page until the data is fetched and then rendered. The second and most important benefit of server-side fetching is better SEO. Search engine crawlers can more easily index content rendered on the server as the content is already provided in HTML format. In contrast, client-side fetching may result in content not being visible to crawlers right away, since it first needs to be fetched and then displayed on the UI, which can negatively impact your SEO. Next, not only is the code shorter, but the logic is simplified. Server components allow you to keep data fetching logic on the server closer to your data source. This can simplify your component logic and reduce the need for useEffect and useState hooks. And the next benefit is not that easy to understand at first, and it is automatic request deduplication. Next.js provides that automatic request deduplication when fetching data on the server, which can improve performance and reduce unnecessary API calls. Basically, request deduplication makes sure that when the same data is requested multiple times at once, only one request is sent. It stops duplicate requests from being made. And when talking about benefits of the server-side fetching versus client-side fetching, I really can't miss on improved security. Keeping API calls on the server allows you to better protect sensitive information like API keys, which should never be exposed on the client side. And adding to the list of benefits, we have reduced network waterfall. Client-side data fetching often leads to a network waterfall where requests are made sequentially. Server-side fetching can more efficiently parallelize those requests. I'll teach you how to do these parallel requests in our build and deploy project, so keep watching. But this isn't just about fetching. You can server render any other calls, maybe a direct database call to Prisma to get the list of posts, or even with Mongoose and MongoDB like this. That's the beauty of Next.js. This is achievable because these components are React server components, which allow you to access server-related resources directly. This means we can make direct database calls instead of needing to create an API and then fetch that API once again. And if you're still not convinced, you can always go for client-side fetching. How? Just add useClient at the top, bring back the use effects, the use states, and you're all set. Next.js will allow you to do whatever you think is best. And let's be honest, this is how we all used to use Next.js when we first transitioned over from React. It only feels natural, but it is the wrong way to use Next.js. And that's what made me create the whole Ultimate Next.js course in the first place, to teach Next.js the right way. But now take a moment to test both client-side and server-side rendering. You'll notice the differences I mentioned, such as seeing the blank page initially with client-side rendering, or if you inspect its source and see that nothing is there, or client-side not functioning at all if you disable JavaScript. In contrast, server-side fetching will still display the results even if JavaScript is turned off in the browser. I have to tell you a bit about API routes. Enough with front-end stuff, optimization, caching, performance, and all that. It's time for some backend work. If you've ever done some backend, even creating a simple hello world from server message requires a fair bit of setup. It involves setting up a project, installing necessary packages like Express for Node, writing server code, setting up Express, the port, and then making that port listen, running it, and then deploying it using some paid or free service so you can finally use it on the front end. It might not seem like a big deal when you're just reading or looking at the code, But things quickly start getting complicated when you have to write various routes, middlewares, and so on. But in the newest version of Next.js, it's super simple, much closer to what we did on the front end. You just create a special file within a folder for the specific route, and you're all set. There's no need to set up, manage, or monitor an active server separately. If you want to show the same message, hello world from backend in Next.js, you simply need to create a folder with any name and then create a special file named route.ts inside it. From there, you can immediately begin writing server code. Export async function get, return response.json, message hello world from backend. That's all there is to it. Your folder name serves as your API route name with your business logic neatly encapsulated within this special route file. If you now go to the browser, modify the URL, and add hello world to it, you'll see hello world from backend as a response. But how can you create other API endpoints like post, patch, delete, and more? Well, for that, let's create a book endpoint with a local array as a database. A common practice when creating route handlers is to create a folder called API and write all the routes inside it. So create this API folder in the app directory and add a database file for storing some dummy books. Then you can create two routes, get and post, in app API books route.tsx. These are nested routes similar to what you explored previously in the routing part for the UI. For the delete and put, you'll have to create dynamic route handlers. And you already know how to do that. App API books and then dynamic square brackets ID /route.ts. And inside of it, you can export async function put for the update request and then export async function delete for the delete request. And then you can add the logic. So far, this feels good. Similar to what we did with UI routes, but this time for writing server code and creating APIs. So let's test them one by one to see if they work or not. And there you go. Everything works perfectly. This is how route handlers or APIs work in Next.js. It's super simple and straightforward. And the creation of APIs in Next.js was nice, but how can you use them on the UI? Well, it's a simple fetch. Just create a books route real quick and call the get API route to fetch the content. Const response, await fetch, localhost 3000 API books. You get them from the response, set them to the state, and render them. If you visit the books route, you'll see all of your books. As easy as it could be, thanks to the serverless architecture of Next.js and React 19 React Server components. And let's talk about caching. Caching isn't new, but in Next 16, it's been completely reworked. So what is caching? It simply means storing data temporarily, so it can be reused instead of refetched or rebuilt. In Next.js, caching happens across multiple layers. There's a browser cache, which saves static files locally. There's the server cache, which stores pre-rendered pages and API responses. And then there's the data cache, which remembers fetch data to avoid repeat requests. Together, they make your app feel instant. So let's talk about the new caching model. See, the old modes like the SSG, ISR, and PPR still exist, but now they're just outcomes of how you define cache boundaries, not separate settings. You no longer choose SSR or SSG. You simply define what gets cached, and Next.js handles the rest. You can enable this new system by simply adding an additional flag to your Next config. Caching is disabled by default, so you must explicitly decide what to cache. Like use client or use server, you can mark routes, components, or even functions with use cache. This tells Next.js to store and reuse the output if inputs haven't changed. For example, you can define it on a file level, component level, as well as on a functional level. Simply placing use cache at the top of a layout or a page pre-renders it at build time, stores it in memory, and then revalidates it automatically every 15 minutes by default. If you want to fine-tune how cache works, there's the cache life method, which controls for how long data stays cached. You can write it something like this: use cache at the top, import cache life, and then define cache life maybe hours, which is going to cache the data below it for 1 hour. You can also define custom lifetimes in your config, and you can also use cache tag to group cached items for easier invalidation. Cache life controls when to clear, and cache tag controls what to clear. To refresh constant instantly, you can just use revalidate or revalidate tag. Now, when talking about caching, we also have to talk about partial pre-rendering, or PPR. See, with cache components option enabled, you don't need PPR set to true. Static parts marked with use cache are pre-rendered automatically, while dynamic parts stream in with React suspense. The takeaway here is that this is a completely new caching mindset. Same principles, different syntax. It will take some time to adjust, but once you do, it'll give you precise control and better performance. Let's just hope that we don't see use in next. Jokes aside, I already started working on the new caching module within the Ultimate Next.js course. But now let's talk about something even newer, a feature that'll make deployment and scaling way more flexible. After v16 of Next.js, we also have build adapters. They're currently in alpha, and it's a big deal for everyone using Next. Until now, the Next.js build process was tightly connected to how Vercel worked behind the scenes. That made sense. Vercel created Next, but things are changing. With the new Build Adapters API, you and hosting providers can hook directly into the build pipeline and customize it. Think of an adapter as a small bridge that teaches Next.js how to build for different environments. Adapters can modify your Next.js config before build time, transform the final build output, or adjust how your app runs depending on where it's hosted, be it Vercel, AWS, Cloudflare, Netlify, or even your own server. This means zero config deployments on any platform, environment-specific optimizations, and most importantly, freedom. Because now you're not tied to just one provider. It's the start of a more open and flexible Next.js ecosystem, so it's definitely something to keep an eye on. One final thing I want to teach you before you're ready to start creating your Next.js application, and that is search engine optimization. Specifically, how we use metadata in Next.js to improve our SEO. And when I mention metadata, I'm referring to the look and feel of our website when we share it with others on messaging platforms or post it on social media platforms or on internet in general, like for example in search engines. In today's world, we need to ensure that our content is shareable. So there are two ways in which we can manage metadata in our Next.js application. The first one is config-based. All you have to do is create a JavaScript object in the layout or any kind of page file and export it. Next.js will automatically detect it and turn it into relevant meta tags for those routes. Something like export const metadata is equal to, and then in there you can provide all sorts of different SEO properties such as title, description, thumbnail, and more. Because it's higher on the priority list, it'll override the default specified in the global layout. This allows you to either define unique metadata for each route or rely on the metadata from the root layout. It's entirely up to you. But everything we discussed so far is just static metadata. Means that it's not going to change. Home is always going to be home. But there are also going to be cases in which you want to create dynamic metadata based on some kind of content on the page, such as a blog title. It's super simple. The only thing you have to do is export a new async function called generate metadata, which gets access to params. Params being the same params that we had before from dynamic routes. You can extract the ID or the name or anything else. Based on that ID, you can get full resource details or user profile details, whatever it is. Then you can use those details to formulate SEO title, descriptions, thumbnails, and more, And you can simply return a dynamic object of all of these properties. That's it. As simple as that. Are you with me so far? Good. And the other way in which we can set metadata in Next.js is file-based metadata. As the name suggests, you can put files like a robot, sitemap, favicon, open graph images, or other site icons directly inside the app folder, and Next.js will automatically detect and generate corresponding meta tags. For example, you can have an app and then a favicon and then an icon and then an open graph image, Twitter image. All of these properties will get added to your meta tags. It's just about adding the files with the right names. They have to be proper names directly inside the app folder. It'll work out the same as the config-based approach. You can find a full list of all files that can be created to define metadata here. But for the time being, I still prefer creating it by exporting the config file from layouts or individual pages. And it's worth noting that file-based metadata has a higher priority and will override any config-based metadata. So if you set it in a file, it'll be used instead of the ones that you set in the configuration. So now you know how to make your apps shareable, SEO optimized, and search engine crawlable. With that in mind, I think you're ready. First, there was a lot of theory, and then there was more theory disguised in this practical part, but now you're ready to dive into code. You're ready to dive right in and build and deploy your Next.js app with all of these optimizations, performance updates, and new features baked right into it. And now comes the more exciting and hands-on part of this crash course. While understanding the theory is essential, knowing how to apply it is what truly sets you apart. So let's put everything you've learned into action by building and deploying dev events. At first, it might seem like a boring application. Just 2 pages where users can browse upcoming events, view details, and book a spot by entering their email, like a newsletter sign-up. But I've chosen this idea for a reason. Behind that clean, modern UI lies a full-stack learning experience. See, by building this app, you'll get practical exposure to file-based routing, React server components, client versus server components to understand when and why to use each, database modeling, where you can design and structure backend data layer, API routes that you can build and connect your frontend to them, server actions to perform server-side mutations securely. You'll also apply the new use cache caching model for instant updates, and then we'll also track the analytics of our platform to understand how our users interact with it. This project will walk you through design, development, and deployment, all the core stages that bring any application to life. So let's dive right in. To start developing your app with the framework used by some of the world's largest companies, we can start with a single command: npx create next app at latest. But first, we have to set up our coding environment so that we can actually paste that command somewhere. I'll be using WebStorm as my IDE, as of recently, it became completely free for non-commercial use. I'll leave the link down in the description so you can download it and try it out too. Once you open it up, you'll be able to quickly create a new project. I'll start with an empty project and name it Next.js Crash Course. Create it and open it up. Then you can open up the built-in integrated terminal and paste the command you just copied. But make sure to add a dot at the end, which will make sure that the application gets installed within your current folder. And then it'll ask you whether you would like to use the recommended Next.js defaults, such as TypeScript, ESLint, Tailwind CSS, App Router, and TurboPack, to which we'll say yes, this is the exact tech stack that we're using. Then it'll proceed with installing the necessary dependencies, which there are very few of, such as React, React DOM, and Next, and then also dev dependencies from TypeScript and the corresponding types over to Tailwind CSS and ESLint. Once it installs, you can run npm run dev to run it on your localhost 3000, and then open it up. We get this new and updated boilerplate page, which looks even simpler than before, and it says, looking to get started, just edit the page.tsx file. So let's explore the app structure. You can see that not a lot has changed. we still have this page, which contains the bulk of the content. So let's go ahead and remove all of it and just run rafce to quickly spin up a new React Air function component with exports. React imports are no longer necessary, so we can just say, welcome to Next.js 16. If this command didn't work for you, you can head over to your plugins or packages and search for React snippets. In this case, I'm using modern React snippets. If you made the changes, you should be able to see that now it says just welcome to Next.js 16 on your localhost 3000. Now, throughout this course, I'll teach you how to build a dev event Next.js application. I found this to be the perfect project to go over all the primary, but also the latest Next.js functionalities. So together, we'll explore what Next.js has to offer while building a couple of these beautifully designed and fully mobile responsive pages. Of course, the focus of this course is the main star of the show, which is Next.js, so we don't need to focus too much on the CSS. For that reason, in the description down below, you'll be able to find a complete media kit containing the link to the Figma design, which you can explore and rebuild on your own if you want to, a complete source code, as well as some snippets that are going to make the building of our application easier, allowing us to copy very lengthy and redundant presentational stuff and allow us to focus only on what matters. So let's start with copying this globals.css file and then heading over within our application, app, globals.css, select everything and overwrite it with what we copied over from the globals.css within the snippets down below. What we're doing here is just setting up the base theme of our application with some styles that we'll be using later on, modifying the color of the body, as well as adding some helper utility functions that are going to help us style different headings, navigation items, and more, and then some components for the hero sections, events, cards, and so on. Now, you can see that this CSS file also requires us to install TW, Tailwind Animate CSS, so go ahead and install it too. It is a dev dependency that some styles require. So open up the terminal. In this case, this terminal is already running the application, but thankfully WebStorm allows us to open up multiple terminals. So I'll say app, and then I'll open up another one, which I'll call just terminal. Within here, you can run npm install --save-dev tw animate css. And as soon as it gets installed, you should be able to see that this red squiggly line will be completely gone. There we go. Here it is. Now, alongside all the styles, there's also a couple of different icons and images that we'll need for this application to look this good. Starting from this little logo icon to maybe some images that we can use for the events. Or maybe we have some icons that we want to use here. You can see that we're using this very cool icon style. So I took some time to find them and I'll give them to you right here within the assets folder. So in the video kit, click on the assets, download them. Don't worry, there's no viruses on there. Once you download them, you can unzip them. And here you'll see a public folder. So what you can do is delete the current public folder and then simply drag and drop this new one in, as well as drag and drop this new favicon that we have for our application into the app folder to replace the current one. Now, if you open up the app, it'll still be more or less the same as what we had before, but let's actually put it side by side by our IDE so we can see the changes we're implementing live as we code them. So I'll drag and drop it right here to the side and give it some space. Now, you can see under the tab name that the logo changed, or the favicon, but the title is still Create Next App. So let's go ahead and modify that by heading over into App, Layout.tsx, where we're importing different fonts, and here's the app metadata. So what we can do is first change the metadata to the real app name, such as dev event, which actually is the hub for every dev event you mustn't miss. That's exactly what we'll build. And we'll also be using a bit more interesting fonts. So let's go ahead and update these two fonts that we have, not Geist and Geist Mono. Rather, we'll be importing, now bear with me when it comes to the title, Shibasted Grotesque. This is the font we'll be using. And we'll also add the Martian Mono, okay? from font Google. So let's go ahead and define them right here. This is the, whatever the name is, grotesque. We can use the camel case right here, and we'll use this name to create it. I'll give it the actual variable name, just as the actual name is. And you can see my WebStorm is complaining about this not being an actual word, but believe me, it is. So we are gonna save it to the dictionary. Same thing for the grotesque, so that in the future, it actually knows that this is a real word. Okay, and the same thing for the Martian mono. We can call this font Martian mono, and we're gonna get the Latin variant of it. Perfect. Now that we have declared the metadata, we can change these two fonts below by saying class name, Shipstead grotesque, as well as the Martian mono. Perfect. And let's fix this variable name right here. So it's actually Martian mono. So now we'll be able to use these two fonts across our application. And we can also add the min h screen, which means that the whole body will take the minimum of 100% of the screen, because everything should actually fit in there. Perfect. So we can still see just the regular welcome to Next.js 16 test, right? To make it a tiny bit more interesting, we can head over to that page and switch it over into an h1 tag, which will automatically make it inherit our Tailwind styles. Why? Because in our globals.css, if you search for h1, we're applying the following styles to every single element. Don't worry, whenever we're using some complex class names, I'll always explain how these styles are actually getting applied, just as we did right here. And since we're working on the layout right now, keep in mind that our design has this very interesting, I don't even know how to call it, like a ray design. You can see rays of sun, some bluish, greenish sun popping from the top right corner. So while we're working on the layout, since every page has it, we can immediately go ahead and implement it. For these rays of sun, I found this very cool React Bits library, which is a component library for creative developers. And I just want to give them a quick shout out for this component. You can see how the rays actually follow the cursor, and they provide you with the full code for it. So you can just Google for React Bits light rays, or I'll leave the link down in the video kit. Then head over to the code and follow the installation and the usage. I'll use the CLI installation, so it's gonna automatically do it through ShatCN, which is another huge advantage. So switch over from manual to CLI and copy the command and paste it within our terminal. It'll ask us whether we wanna install ShatCN. That's for sure gonna be a yes. Then when you get asked some questions, such as whether you wanna create a components JSON file, say yes to that, and then which color would you like to select as the base color? Let's go over with neutral. It'll add all that info within our components JSON. Now what you can do is create a new component within the components folder. So first generate the folder itself called components, and then a new file called lightrays.tsx. You can go ahead and automatically copy the code over from here, but to make it fit a bit better with the design, I made some changes to the component and provided the updated version to you within the video kit down below. So you can just copy it from components UI lightrays. So just go ahead and paste it into this file we just created. You don't have to worry that there's so much code here. You can think of this as a typical ShatCN component that you do not touch. The only thing I've done is added the top center offset, which will move the trays a bit so it looks exactly as it does in the design. Now we want to apply these light rays to the whole application by putting them inside, not of the page, because then we have to do it for every single page, but rather inside of the layout, because what happens here will actually be translated over to every single page that is within this layout. So right here at the top of the body, go ahead and copy the usage part of the light rays from the documentation and paste it right here. You have to auto import it from lightrays component lightrays, and we can change how it behaves, starting with rays origin, which I'll set to top center offset. If you head over to your application, you should be able to see how it looks like. We definitely want to remove this import statement. There we go. And we don't need to put it into an additional div. We just want it to be there right within the body. There we go. So you can see how the rays are moving right now. And we can also change the ray color. I found the color of hash 5DFECA to work nice. It has this greenish hue. You can play with the ray's speed. I'll set it to something like 0.5 for them to be a bit slower. The light spread can be around 0.9. Ray length will be about 1.4. Follow mouse can be set to true. Mouse influence, I will lower it significantly because the goal of this app is not for the users to play with the actual rays. It is for them to check out dev events. So whenever you're implementing some animations, you want to make them simple. The noise amount can be set to 0, and distortion can be set also to a minimal amount with no need to provide a custom class name. I will put the rays into a div like it was before, but I'll provide some different class names, such as absolute. This is very important because this will position the light rays absolutely on the page, which means that it'll not interact with the rest of the elements on the page. I'll also inset it to the top by saying inset 0 and top 0, giving it an index of z minus 1. So that way it appears behind the elements with a min h of screen. Perfect. And I'll also give the children the main tag. So they'll be wrapped right within the main of the application. That is where we'll load the actual content of the page. Perfect. So welcome to Next.js. The rays are at the top. Finally, within our page, to make it look a bit nicer, we can wrap this into a section. We can give it an h1 within that section that'll have a class name equal to text-center, and it'll say the hub. For every dev, we can add a break tag in between. Event, you can't miss, similar to what we had in our layout. And then we can have another p tag right below it that'll say something along the lines of hackathons, meetups, and conferences, all in one place. And I like it how WebStorm actually catches the typos, not just code mistakes. So I can just hover over it and automatically fix it. And I'll give this p tag a class name of text-center, as well as a margin top of 5 to divide it a bit from the main title. Okay, we have the main content, but what happened to the styles? It seems like we don't have that dark background we used to have. That's because after we installed this package, it went ahead and modified our globals.css. So just once again, go ahead and copy the final one, head over to the globals.css file, and override it. If you do that, you'll notice that the styles will be there, and you'll also see very light rays at the top. But if you extend it to full screen, you can see that they're much more pronounced, but still not taking away from the overall experience of the application. So just like that, we've successfully set up our project, and we can already see something on the screen. In the next lesson, let's develop even more parts of the homepage UI. Let's start developing the other parts of our homepage, starting with this Explore button. We can create it as a new component. Right here within our components folder, I'll create a new file called Explore btn. .tsx. We're creating a separate component as button is associated with event listeners that have to happen on the client side. This kind of thinking is necessary when developing Next.js applications because it's all about server-side rendering. See, I'll run RAFCE right here to quickly spin it up, and you'll get a better idea of what I'm saying. This component will be a button, specifically a button that we're using within our page. So let's immediately go ahead and import it below our p tag, Explore btn, as a self-closing tag. There we go, you can see it right here. Now keep in mind that our homepage is server-side rendered. We're getting all the benefits of SEO boost as well as quick load times, but we still need some kind of functionality for this button because buttons will eventually have on-click listeners where, for example, we want to perform an action. For now, that action can be just saying that we clicked it. But as soon as you give it an on-click listener, that means that you have to turn it into a client component. So that's the reason why I turned this button into its own component. So now I can add this use client directive at the top. You can read a bit more about server and client components within Next.js documentation, where it explains how they work and how these are basically two entirely different contexts and environments. Client refers to browser on a user's device that sends a request to a server for your application code, and the server refers to the computer in a data center that stores your application code. What's important to note that each has its own set of capabilities and constraints. And I dive super deep into this within the Ultimate Next.js course, where we cover application navigation, the state management, and how we can handle it on the server side through URL state management, and finally, diving into thinking in backend when it comes to Next.js applications. Same things goes for server actions. How do they actually work and how do they work on the server specifically? And then, of course, different approaches when rendering components, whether on server or on client. But with that in mind, we now have this button that is a client component inside of another server component. So this is rendered on the server, but if you need some extra functionality, you can render it on the client. That's all I want you to know for now. So we can give this button a type equal to button, an ID equal to explore btn, with a class name of margin top of 7 to divide it a bit from the content, as well as the margin X of auto. Within this button, we can render an anchor tag to make it a link pointing to hash events, which will show below the button. It'll say explore events, and right below it, we'll actually render an image. So this is a Next.js image, so we can import it from there with a source of /icons /arrow-down.svg with an alt tag of arrow-down. And we can close it right here. We'll also have to give it a width of something about 24 and a height of 24, so it actually appears as it knows its dimensions. There we go. Explore events. And it looks like my styles were not getting applied, so I simply repasted the final globals.css into the public and resaved all the files, and it looks like right now we're good. And I just want to recap this situation one more time, because it might be counterintuitive, and in this crash course, I don't want there to be any confusion. The goal is to make this the best Next.js crash course you watched with all the questions answered. So if at any point you're confused, leave the timestamp of where you're at the video in the comment, and then write your question and I'll clarify it. That way, we'll be helping out each other. I mean, that's kind of like what we're doing in the Ultimate Next.js course, where in the architecture lesson, if we dive into client versus server paradigm, there's a complete lesson on the topic, and then below that lesson, we have the comments. For example, Robin was confused between server-side rendering and server components, and that allows us to provide a much more detailed response to his question specifically, as well as other people can ask questions or just contribute to the overall learning process. Okay, but why did I even start talking about this? Well, that's because it might feel super weird that we have already split this explore button into its own component. Usually, you won't start by building client components right away. Instead, you'll create them as you encounter specific client-side needs, such as the need for an on-click listener right here. In many cases, most of your features will run on the server side, but there will be many times where certain parts just need to be implemented on the client. And that's where this architectural mindset becomes incredibly valuable. It'll help you decide exactly which parts should be rendered on the server and which should be handled by the client, instead of just defaulting to one side. I'm happy to say that that's also covered within the Ultimate Next.js course. Here's a lesson summary and its full transcript. And people in the comments are also discussing how this works on different types of large-scale applications, such as within an e-commerce app. So if you haven't already, definitely explore the Ultimate Next.js course, now bundled with the complete testing course, so you can also later on test these server and client components. I'll leave a special discount link down in the description. But now let's develop the rest of the homepage. Below the button, I'll develop another div That div will have a class name equal to margin top of 20 and space y of 7 to give it some breathing room. And it'll have an h3 that'll say featured events. Below it, we can map over a couple of elements in an unordered list with a class name of events, where I'll create a new dynamic block of code where you can create an array that'll just have numbers from 1 to 5, and we can map over them. Each one of these numbers will later on present a full object containing that event's data, and then we can automatically return a new list item. When I say automatically return, I mean not opening up a function block with curly braces here, but rather just putting parentheses, which means that we don't even have to define return, rather it returns it by default. Since we're mapping over this, we have to give it a key equal to event, and I'll say event. So it should say event 1, 2, 3, 4, 5. So let's create a new component in the components folder, and I'll call it navbar.tsx. Within it, we can run rafce to quickly spin it up. We'll use semantic elements, such as header in this case, and within it, a nav. This helps screen readers and in general improves your web app and its SEO because browsers better understand the elements on your app. Then I'll render a link component right here. This link is coming from Next.link, so you can automatically import it. And I'll make it point to /, which is just the homepage, with a class name of logo, within which we can then render an image, also coming from Next. It's going to be /icons /logo.png, which is the path to the actual logo, with an alt tag of logo, a width of about 24 as before, and a height of 24 as well. If you save it, you won't be able to see anything yet. Of course, that's because we haven't yet put the navbar to use. We'll do it very soon, just after we add this p tag that'll say dev event. This will appear next to the logo, so people know the name as well. And below the link, I'll display a UL, an unordered list, that'll contain additional links. The first link will point to homepage for now, and it'll say home. We can duplicate it 2 more times. The second one will point to the events page, and the third one to the create event form. Now, if you save this, we can actually use this navbar in our layout, not in our page, because the layout will make it appear across all of our pages, which is another great lesson to be taught here. Whenever you're seeing something that appears across multiple pages, such as this navbar appearing here on the homepage, on the details page, and on the admin dashboard, then it's a good idea to put it in the layout. But if something is appearing just on the authentication page, for example, then you can put it on that page directly. These are also some principles taught in the Ultimate Next.js course before I showed you the curriculum, but now I can actually show you the full app that we're building as part of that course, and it's Dev Overflow, the more advanced clone of the full stack Overflow application with complex sorting, filtering, search, and yeah, here you can see that we have the global search right here, which searches across all different types of data in our database, such as questions, users, answers, and so much more. So for example, on our profile page, we can still have this global search, and it's also shared across all the other pages, such as collections, community, homepage. It's everywhere. But for example, it's not on the login and sign up pages. That's because these two use a completely different layout. So with that in mind, let's put this navbar to use right here above our div containing the light rays. I'll simply refer to it as navbar and import it from the proper place. It should look something like this. On smaller screens, we can see just the logo and the links, but when you enlarge it, you can see a more beautiful version of our dev event application. Now let's turn these boring events, which are just pieces of text, into actual reusable events cards. We can do that by creating a new reusable component in our components folder, which you can call event card.tsx. Run rafce to quickly spin it up, and then this component will accept all of the data that it needs to show as props because each event card will show us completely different data. Let me show you what I mean. We can first make it accept, well, let's do a title and an image. These will be of a type props. We're using these props so TypeScript knows what this component is accepting. So right at the top, we can say interface of props and make it accept a title of a type string, as well as an image of a type string, as we'll pass over a URL. Then we can immediately return a link because each one of these cards will be clickable, pointing to the full events details page by having an href pointing to, for example, for now, we can leave it as just /events. We'll change it later. And an ID of event card. Within it, we can display an image with a source equal to image. And right below it, a p tag where we're rendering title with the class name of title. Don't forget to import the image coming from next image. And we also have to give it the alt prop, which is going to be rendering the title, the width of about 410, the height of about 300, so it looks like a banner format, and a class name of poster. Now that we have created this reusable event card, we can head back over to our page where we're mapping over these 4 events. And instead of just mapping over the numbers right now, we can actually create a new events array, which will have 2 objects for now. It can have a first one that has an image of /images /event1.png, and it'll have a title of event1. I'll duplicate it to create the event2 and event2.png respectively. Now we can map over these 2 events by saying events.map. And this time we won't just be rendering the event number, rather we'll be rendering a reusable event card like this. That still will be within its own li. So I'll create a list item with a key equal to event.title. And within it, we'll render the event card to which we will spread all of the event properties like this. Immediately, if you do that, you'll be able to see 2 new featured events, event 1 and event 2, showcasing their images. Now we have to focus on passing some other important event data as well to make each event even more distinctive. For this, we can refer to our design. Like, what other important pieces of info does each event have, so we can create those events in the database later on and then use this reusable event card component to render completely different pieces of data. Of course, we have the location, this one right here. Then there's the image and the title, as well as the date and the time. And finally, we need some kind of an ID or a slug, allowing us to redirect to that event's details page. So let's go ahead and define those pieces of data right here. Alongside the image and the title, we'll also have a slug that's going to be something like event1. We'll have a location equal to location1, as well as a date set to date1, and finally a time set to time1. Pretty unimaginative, right? But I think this is really the part where it makes sense to include an AI coding agent that can help us when we need help. I typically use Junie for much more complex tasks because it can really do a lot, but in this case, we'll use it to generate some meaningful data for our events. I'll leave the link down in the description so you can download it and use it alongside WebStorm. It is super convenient. I press Command-Shift-P and just search for Junie. It immediately pops up right here. You get examples of what you could ask it to do, but in this case, we can just ask it to create a new file, which is going to be in libconstants, in the root folder. It should export an array named events containing real upcoming conferences. I'll leave this snippet so you can copy it in the video kit down below, and you can just paste it here. Now, just before I let Junie generate things, see here that I said that we need to make sure that the data looks realistic and can be directly imported and used in the event card component. Since I said this, it's very important to dive into the event card and make sure to update the props so it knows exactly which fields we're expecting to use. This will include the slug that we created, also the location. It'll include the date, and finally, the time. TypeScript is super useful, not just for us, but also for AI agents to know the structure of the application and to just align the expectations. Now that this is done, we can go ahead and let Junie do its job. This typically takes about half a minute, so I'll let it do its work and I'll be right back. And even sooner, it created a new constants file, so we can head over into it. Directly within lib constants, there we go, curated list of upcoming popular dev events. It created and exported an event item so that we can now easily import it. So we can easily use it across whenever it needs to be used. And then there's some other events right here. So let's go ahead and easily use them by heading over into our page. Instead of creating our own array of events, we can now very easily just import these events coming from lib constants. So we're not cluttering our view right here. And just like that, you immediately get all of these other events listed right here. So now we can head over into this component to display all of these additional pieces of data that we now have. Let's first get all of these props, such as the slug, the location, the date, and the time. We will use the slug right here in the URL, so we can point to it. In between the image and the title, I will also display a div that'll display the location. So this div will have a class name equal to flex, flex-row, gap of 2, and we'll render an image that has a source of /icons/pin.svg with an alt tag of location, a width, very small, of about 14. Height can be set to 14 as well. And then just below it, I'll display a p tag that'll render the location. There we go. Some are happening in San Francisco. This one says Vienna, but I believe it was actually in Croatia. There's also Los Angeles, Paris, and Vancouver. Alongside showing the location, let's also display some additional date and time information below the p tag. So I'll create a div with a class name of date time. And within it, I'll display a div that'll be very similar to this div. It'll contain an image for the icon and then a p tag for the actual info. But instead of it being a pin, it'll be a calendar with the alt tag of date. And then this will render the date. The date is here. Now I can duplicate this div just below. And this time we'll change it over to clock for the time. And then we can render the time. Perfect. This now feels like a real event card. So now if I expand our screen, take a look at this. The navbar looks great on desktop. So does the hero section. We can explore the events. And then there's a list of all of the most popular dev events around the globe. Looking good already. Now, this is the point in time where we actually have something tangible and visible on our app. So what do you say that we follow the best practices of writing code in general and actually ship this code over to GitHub? It looks like GitHub is preparing for their own conference, but I've closed that because we have our own app that tells us about dev events. So now let's go ahead and create a new repo. I'll do it on my personal profile and I'll call it dev events Next.js 16 crash course. Let's go ahead and create the repo. Once you do that, you'll be given the steps needed to connect it to your local repo right now. So let's just follow them by opening up the terminal and running git init, git add dot, git commit -m, first commit, git branch -m main to open up a new branch, and then git remote add origin with the URL of your repo, and finally git push u origin main. This will take all the existing code and push it over to GitHub. While we're here, we can also provide some additional info by copying it from our layout, the hub for every dev event you must not miss. That's the description. For the website, we'll be able to put it later on once we actually deploy it. But for now, I'll say jsmastery.com. For the topics, we can say Next.js and Next.js 16, and we can hide these to make our repo a bit cleaner, but I'll make sure to add HTTPS right here to the URL and save it. Perfect. Now, as we continue developing this application, and I would highly advise you to do this for all the upcoming applications, always push over to GitHub. It's super beneficial for so many reasons. Anybody can head over to your GitHub profile and check out your contribution graph. The more you push, the more active you are. Your projects can also get noticed, and most importantly, potential employers are gonna look at your commit history. Not your browser history, don't be afraid, just your commit history, where we need to make sure to use proper commit names. So for every single feature moving forward, we will not only write proper commit names, but we'll also be opening up different branches and pull requests so we can verify that the code that we actually write is of high quality. CodeRabbit here will be of great help, as it'll help us cut that code review time and bugs, well, in half, right? So starting from next feature onward, you, me, and the rabbit will be reviewing all of our code. So click the link down in the description to start with a free trial of CodeRabbit. It's also available in many IDEs, and one of their newer features are CLI reviews, which means that you can get instant code reviews directly from your terminal while you're developing the app. We'll explore all that and more very soon. But for now, just so we don't forget, let's immediately create a new branch for the feature that we're going to start developing next, and that is implementing PostHog. So you can say git checkout to immediately move to this new branch, and -b to automatically create it, implement PostHog. There we go. If you've done that properly, you can just switch over to this new branch, implement PostHog, and I think that gives you a pretty good idea of the feature that we'll develop next. So let's do it. Now that our homepage is up and running, it's time to shift our focus from what we've built to how do people actually use it. Because here's the thing, even the most beautiful designed app isn't truly valuable until we understand how users interact with it. Are they visiting the pages we expect them to visit? Or are they just randomly clicking around? Where are they dropping off? Are there errors happening behind the scenes that we are unaware of? That's where PostHog comes in. It's an open source analytics and product insights platform that helps us answer all these questions and more. With PostHog, you can automatically track user behavior, see how different features are performing, monitor errors in real time, and even capture valuable metrics that guide future development. And I'm actually including this step in the project because this is how real-world production apps are built. It's not just about writing code. It's about creating something that evolves based on user feedback and data. But you might be wondering, why are we setting this up now, right after building the homepage and before diving into the rest of the features? The reason is simple. Analytics are most valuable when they're a part of the development process from the very beginning. By integrating PostHog early, we ensure that every new feature we add will be measurable and trackable from day one. This approach reflects how real-world SaaS products are built. Heck, the entirety of jsmastery.com is fully tracked by PostHog. Seeing what you guys do on the platform, where you click, how useful specific features are, matters so much to me. So that's why tracking these data pieces with PostHog allows us to continue shaping the platform based on user behavior, not just intuition. So in this lesson, you'll learn how to set up PostHog inside of our Dev Events application. And together, we'll explore its features. This will allow you to integrate PostHog into every single one of your upcoming Next.js applications to make them intelligent, data-driven platforms. Because the process is more or less the same. So let me show you. To get started, click the PostHog link down in the description. And just check out this super unique landing page. I'll have to just ignore how cool it is for now and just show you how we can get started. So click this link right here. You'll have to choose your region and then sign up through one of the providers. It'll ask you to create a new organization. So type JS Mastery. Then you can select your role. And if you have a second, You can also tell this hedgehog that you heard about it from me. So say Adrian or a JS Mastery is fine as well. And let's create the org. Now it'll ask you which products you would like to use. You can select whatever you want. I want to use product analytics, web analytics, data warehouse will be useful, session replays. Later on in upcoming videos, we might even dive into feature flags and experiments. Surveys are great if you want to just get a quick NPS score or user satisfaction score. And then, of course, error tracking. That's what we're here for. So I'll actually go ahead and select everything. Starting with product analytics, let's go. I just realized that we're still looking at a light color theme. So at this point, you can just switch it over to dark mode. That's much better. Now, the next step is to install PostHog to make it run with our application. Believe it or not, Next.js is at the top of the list of all of these frameworks, and that's exactly what we want to use it with. As I told you, this course will teach you how to use PostHog with every single one of your upcoming Next.js applications. Now, you can copy this AI setup wizard command. This AI wizard should install and configure PostHog automatically. So here you have to choose your PostHog cloud region. It'll try to authenticate you. It'll install PostHog.js, PostHog node, review the documentation for Next.js, create all the necessary files, and basically set it up for you. If you're using an AI-powered IDE, you'll also be asked if you want to install the MCP server to use PostHog in your editor. That will teach your AI how to use PostHog. In this case, I'll skip it, but that's definitely something we can explore in the next video. And that's it. Successfully installed PostHog. What this installation did is it created a new file called instrumentationclient.ts, and it also added PostHog's environment variables to your .env file. Now, as soon as PostHog captures the first event within your application, it'll let you know that on the setup page. So if you head over to localhost 3000 and try clicking around a bit, you'll see that it auto-captured an event a few seconds ago, and with that, the installation is complete. So let's continue. Here, it's asking us what we want to use PostHog for to auto-capture front-end interactions, enable heat maps, enable web vitals, and enable session recordings. I'll say yes to all because these are all great features that we don't want to miss. Let's continue. And now I think this is the best part. There's both a completely free plan that allows you to have one project, and then there's also the pay-as-you-go plan, but with the free tier included, which starts at $0 per month. And I'm not sure if I'm allowed to say this, but PostHog's free tier is the best in the game. I really mean it. It is highly likely that if you're using PostHog on your personal projects, you'll never cross the free tier. If you start using it on your apps that grow and have so many users, then it's still super cheap. But then we're hoping that you're making money off of this app, right? So for now, I'll go ahead and proceed with the free plan. You can invite teammates if you want to, and we're in. Now, I've zoomed it out a bit so you can better see what's happening here on the screen. On the left side, there's a left sidebar allowing you to get to different parts of your dashboard. In the middle, you have this browser-like explorer where you can see all the different insights. And then on the right, there's the quick start guide where you can learn everything about PostHog. I would actually advise you to go through it to learn a bit more about how it works. For now, I'll skip inviting a team member because we're working on this solo. And then we are ready to create our first insight. So click on that. What this allows you to do is to analyze user behavior patterns in your product. You can visualize events, actions, and properties to understand how people use your app. So let's start by quickly creating a new insight. Even though we don't yet have too much data captured, we can already set up a simple page view insight to see how many people visited our app up to this point. So right here at the top, you can say Home Page Views, then select the page view and the total count, and switch this option over to a cumulative line chart. Once you've done that, click Save, and that's your first insight. So now if you head over to the home page, you can see some insights created for us on your dashboard, but you can also head over to Dashboards and create a new dashboard that'll have access to this new insight that you created. So insights go onto dashboards. There we go. You're now tracking general app usage. That can be the name of the dashboard. And you can see that we have about 4 page views since we set up PostHog. Now, another thing I want to do right from the start is to enable error tracking. So on the left side sidebar under behavior, you can click on error tracking and enable exception auto capture. Now, later on, when you visit error tracking, we'll be able to see all the errors that are happening. And just like that, you now have PostHog successfully integrated within our dev events project. This is the first step toward building truly data-driven applications. An app that doesn't just function, but actively learns, adapts, and improves based on how users interact with it. But this is only the beginning. As you develop more features and grow your platform, we'll revisit PostHog again and again, adding custom event tracking, building some new dashboards, and diving deeper into product analytics. So with every new feature, you'll make your app that much smarter, more intentional, and closer to the kind of the production-ready applications that companies rely on in real-world projects. Great work. In this lesson, you're going to learn how to integrate MongoDB within your Next.js applications. It's a highly flexible, document-based NoSQL database that pairs extremely well with modern frameworks like Next.js. MongoDB stores data in JSON-like documents, which makes it a natural fit for a JavaScript and TypeScript environment. You can structure your data exactly the way your frontend expects it, without complex migrations or rigid schemas. Its ability to scale horizontally, handle unstructured or evolving data, and perform lightning-fast queries makes it ideal for projects that need to grow quickly. That's why I've chosen MongoDB for this project. It's easy to get started with and easy to grow. So head over to MongoDB Atlas and click Get Started. Then create a new account or simply sign up with Google. Once you're in, head over to your organization, and within it, create a new project. I'll call this one Dev Event Next.js Crash Course, and just click Next. Put yourself as the project owner that you are, and create the project. After you have the project, we need to create a cluster, which is basically your database. For this, you'll have to choose the deployment of your cluster. Don't worry, you don't have to pay anything, just select the free version, which is going to be more than enough. Select your region that is closest to you, and click Create Deployment. Now you'll have to create your database user. Simply choose your username and password, which you can copy, and then create a database user. After you've created the user, choose a connection method. In this case, we're going to connect directly with our application using MongoDB's native driver, such as Node.js. We'll very soon install MongoDB within our application, but for now, let's wait until our cluster is provisioned. This can typically take a couple of minutes. When it's done, you'll be able to see a copyable connection string, so just copy it, and then back within your application, head over to your .env and name it MongoDB_URI, and make it equal to the connection string you just copied. Make sure to replace the password with the actual password you generated for your MongoDB user. With that, your serverless MongoDB database is ready to use. So in the next lesson, you'll start using this database to implement the core features of dev events. Before we dive into implementing database operations in our Next.js application, I want to stop and show you a tool I've been using a lot lately. It's Warp, an all-in-one AI-powered development environment built to help you build faster. Instead of memorizing commands and hopping between tools and documentation, just describe what you want in plain English, and Warp will understand, execute, and deliver these results instantly. And the best part is the developer experience you get from having everything together: a terminal, code editor, and agents all in one place. No need to have 3 different browsers, 1 editor, and 10 open tabs just to get some output from an AI. When it comes to pricing, Warp also has a 100% free plan, so you can check it out before making any commitment. For a limited time, specifically for you watching this video, you're getting Warp Pro plan for only $1, which is normally $18 per month. So click the link down in the description and grab it before it's gone. Let me show you how we can set it up. Click the link down in the description and download it for your operating system. Once you open it up, it'll look a bit empty, but that's for a reason. Soon you'll be able to open all the different things needed for you to develop apps right here. Here, you can select from different agents. Auto mode is pretty cool, and you can even tweak it how you like it. But there are more advanced models like GPT-5 or Claude 4 or 4.5 Sonnet, which are right now one of the best models when it comes to coding. And don't forget that Warp is actually a terminal, so you can just navigate over to our repo. So just cd into Next.js crash course and optimize Warp for this codebase. It'll actually let the agent understand the codebase and generate rules for it. So just click optimize, and we'll say index. No need to generate the Warp MD file for now. Perfect. We're now on the implementing PostHog branch. And actually, this reminds me that we've finished the PostHog implementation in the previous lesson. So we might as well commit it. I'll say git add dot, git commit -m, implement PostHog, and run git push. Specifically, since we created a new branch, we want to set upstream to origin to push it to our actual remote repo. A pretty cool Warp feature here is that you can just press Command Enter and it'll automatically fix the command up for you, which is absolutely amazing. You can just say run. There we go, the branch is now pushed. So if you head over to GitHub, you'll see that there is a new pull request to be reviewed. Go ahead and create it. We want to merge it straight into main. And in the upcoming lessons, we'll use CodeRabbit's help here to review this PR, but this one is super simple. We basically didn't write any code besides following along the PostHog implementation guide. So for now, I'll just go ahead and auto merge this one. Now the latest code is all on main, which means that within our code, we can now check out to the main branch, pull the latest changes by running git pull, and we can create a new branch, which is going to be all about what we're going to do next. It'll be about implementing database models. So say git checkout -b to create this new branch and call it database models. And you can immediately see that Warp offers itself to fix a bug or implement a feature within our database models branch. Slow down there, cowboy. First, I want to teach you guys how to think like a system designer, to think about what we need, which data pieces do we need to model, and how our application database structure will look like. Only then can we bring in Warp to help us. So let's do that next. Before you touch a single line of code, pause and think like a systems designer. Data modeling isn't about typing out a schema. It's about understanding the problem domain and asking the right questions until the structure of your data almost designs itself. So start with the most fundamental question. What is the main entity in this application? For dev events, the answer is clear. It's an event. Everything else revolves around it. Now ask, what defines an event? Well, it needs a title, that's the name users will see. It needs a description and an overview, so people know what it's about. It probably needs an image to make it visually appealing. Where is it happening? That's the venue and location. When is it happening? That's the date and time. But those need to be stored in a normalized, consistent way so you can easily sort, filter, and query them reliably. Maybe also how is it happening? Like the mode, is it online, offline, or hybrid? Who is it for? Like that's the audience. And what's going to happen there? Maybe like the agenda or a list of topics or activities. Maybe even who's organizing it, right? If it's a well-known company like Microsoft or Google, that can be there as well. Also, if you're advanced, you might want to think about the organization of how you want to categorize it, so the people can search it more easily for later. That's where tags would come in. And for SEO-friendly URLs, you'll want a slug, which is a unique URL-safe identifier generated from the title. Every one of these fields answers a real-world question, and together, they describe exactly what an event is, not just for your code, but for your product. You're designing them based on real-world requirements. That's how data modeling should always start. But that's only half the story. The next question you should ask yourself is, how do users interact with these events? Well, you could say that they sign up for them or that they book them. So we need to introduce a second entity, booking. So for that, you also need to ask yourself the same questions. What do we need to store for a booking? We need to know which event was booked. That's a reference to the event ID. We need to know who booked it. An email address will be enough. And we also need to track when the booking was made. We can do that with automatic timestamps like created at or updated at. This simple relationship, one event to many bookings, forms the backbone of our platform's logic. And while this might feel small and focused right now, remember that this is just the foundation. In larger production scale systems, a booking could evolve into something much more, like a payment status, different ticket tiers, user profiles, cancellation policies, refunds, and more. This is your starting point, and from here, you're free to grow it in any direction you want. But the one thing I want you to get is the mindset of asking, what should the data do? Rather than just, what data do I need? This is the foundation of backend architecture. You think from the real-world behavior you're trying to represent and design the database so that it naturally reflects that behavior. That's how you go from tables and fields to systems and logic. And that's exactly how large-scale applications are built. And all this is simple architecture. If you want to learn about more advanced data modeling on a real production-level app and understand that systems-level thinking in depth, that's exactly what we do within the Dev Overflow application. Starting from thinking in backend, architecting database structure, and then slowly creating all of these different models within our application with some active lessons, allowing you to actually think and approach things on your own with some hints in order to be able to truly understand how that architecture mindset works. And once you start thinking in that mindset, the rest will become much easier because now the schema is just a technical requirement. And whether you're building a small side project or architecting a massive production system, the same mental model scales with you. By now, you've done the hard part, the thinking. You've answered all the key questions, mapped out the relationships, and defined how your data behaves. So that's exactly where the modern AI development takes over. You don't have to necessarily write all the boilerplate code by hand. Instead, you can use AI to handle the repetitive work of generating these Mongoose schemas, TypeScript interfaces, validation logic, and even pre-save hooks. That's the power move. You architect, AI implements. That's exactly how professional engineering teams work today. They focus their time and energy on designing systems and let automation handle the rest. And now you're going to learn how to work exactly like that. You can think of this segment as an additional course within this Next.js course that teaches you how modern engineers are using AI to their advantage. So head back over to Warp. First things first, we'll use it just as the terminal to run npm install mongoose. That was quick. And now we can use the same interface, which a second ago was a terminal, to write an actual command for an AI model to execute. I took some time to write it in a detailed way so we both get the same output. And you can find this exact text within the video kit link down below as a copyable snippet. Let's go through it together. You're a backend developer working on a Next.js application with Mongoose and TypeScript. Your task is to create a new MongoDB.ts file in the lib folder of a Next.js application, set up a Mongoose database connection to MongoDB using TypeScript with proper types, cache the connection to prevent multiple connections during development, write clear and concise comments explaining key parts of the code, and making sure that code is clean, readable, and production ready. It's quite an open-ended task, so let's see how it does. I'll press enter, and I'll say start a new conversation. It's now figuring out what it needs to do, and it says that it'll create that file for us. There we go. It gave us the file right here so we can review it and potentially make some changes. I'll just press enter to accept it, and that's it. The file was created. You can now open up your Project Explorer by pressing Command-Shift-E and head over to lib mongodb.ts to explore this file. I'll zoom it out a bit so we can see it a bit better. And what happens here is it defined the connection that we can cache because Next.js by default is not keeping a consistent connection. Rather, every time we make a server action call, it'll spin up the server for that amount of time needed for it to execute that server action. Then the next time we're trying to call it, we don't want to generate a whole new connection. Rather, we want to grab the connection from the cache. And that's exactly what it is doing right here. It's returning the cached connection. And finally, it is connecting us to a database using the MongoDB URI from our environment variables. With that, we should now be able to connect the app to the database. Oh, and just so I don't forget, on the left side sidebar in MongoDB Atlas, head over to IP access list and then add an additional IP address by clicking Allow Access from Anywhere. This will make sure that we can connect to our app after deployment without any issues. Now, back within Warp, we want to give it another task. So you can copy and paste another snippet of code within the video kit down below, and we can go through it together. This time, the task is to build a database layer with two Mongoose models, event and booking, just as we discussed in the architecture part of this lesson. Keep in mind that here I'm being super precise. The only reason why I'm doing that is so that both you and I have the same output in the code, so everything is super clear. Otherwise, if I weren't doing this for the video, I would have written a much shorter command. I'm telling it to create exactly 3 files: event model.ts, booking model.ts, and an index file that exports both of them. So in the event model, we want to create a strongly typed Mongoose schema and model called event with the following fields, all of which we have discussed and architected before. I also give it some requirements, such as to create a pre-save hook, which is basically a function that'll take a title and generate a URL-friendly slug so we can use it later on. And I'm also telling it to use the automatic timestamps. Then we want to generate a booking model, same thing here, but much simpler. And then finally, in the database index.ts, we're exporting both the event and booking models so they can be imported anywhere within the application from a single file. So press enter. Looks like it automatically figured out what it needs to do. TypeScript and Mongoose are installed. If Mongoose hadn't been installed, it would go ahead and install it as well for us. But now it'll just proceed with creating those files. I'll go ahead and accept the first one. That's for the event model. Then we can review and accept the second one, which is for the booking model. And finally, one that exports both of them alongside their TypeScript interfaces. It'll even run a TypeScript check to ensure everything is properly typed and valid. Perfect. Oh, another thing is that it self-fixes the linting errors, which is pretty cool. Wonderful. It is done. 3 files had been created, and now we can go through them together to make sure that we fully understand what is happening. I'll open up the File Explorer and head over to database eventModel.ts. I'll expand it and we can go through it together. First, we have the TypeScript interface for this event model, covering all the important pieces of info that our model will have. But then more importantly, we're actually creating an event schema using Mongoose schema that is strongly typed to this event so that at any point in time, our application knows exactly which properties it needs to accept. We have a title, which is required, with a max length of 100, a slug, a description, overview, and everything we discussed before. Now, if you head down, you'll see that there's also this pre-save hook for slug generation. So before we save it, it's actually going to take the title and generate a slug for it. And here's a helper function that generates the slug. Is it an overkill? And could we have done it in a simpler way? Well, definitely yes. But this is more robust, and I'm actually glad that we're able to get to this so quickly. There's another function that allows us to more easily get access to the date in a human-readable format. Perfect. Now, alongside that, you can also check out the database booking model, which is much simpler. Here we have the event ID, which is actually a reference to a real event in our database. We have an email with validation function. And then also, before we save it, we want to validate that the event exists before creating this booking. We also have some indexes for faster and easier queries. If I didn't use Warp and if I was writing all of this by hand, I would most likely be a bit lazy to write this good enough of a validation function for events. Or maybe I wouldn't have remembered to write these queries or indexes. And these are the things that make using AI as a helper great. What we can do now is push this over to GitHub by running git add git commit-m implement database models and git push. Once again, we'll have to set the upstream branch to push it over to a remote repo. Perfect, it's pushed. I know it seemed like we have done a lot right here, or like a lot was done for us, but at every single point in time, you need to fully own your codebase. You need to understand 100% what's happening. So in the next lesson, we'll do a bit of a recap and review what we have done just now. Head over to your GitHub repo, and you should be able to see that our database models branch had recent pushes a couple of seconds ago. That allows us to compare it to the main branch and potentially open up a PR, which is exactly what I'll do. Now, this was a bit of a larger PR, which I definitely don't want to go ahead and just merge to main. Rather, I want to do a proper analysis of what we did within this PR. We implemented the booking model, the event model, the database index that exports both of them, as well as set up a MongoDB connection and installed Mongoose. Now, instead of going through it line by line, I actually want to put CodeRabbit to work. As you can see, it says waiting for status to be reported, review in progress. And it seems like it started processing the changes in this PR. This may take a few minutes, so let's give it some time and a fist bump, and I'll be right back. I just went to grab a coffee, and when I got back, here's the summary created by CodeRabbit. New features that we implemented here, it's going to be the event management system with comprehensive event details containing all of these important pieces of info, such as the title, description, date, time, location, audience, and information, and the booking system for event registrations featuring email validation and automatic timestamp tracking for registration records. We also added the MongoDB database support. Here, we can go through a more detailed walkthrough where we're introducing MongoDB and Mongoose integration with the new event and booking models featuring schemas and validation, indexes, and pre-save hooks. What I like most about it here is the sequence diagram. Yep, it actually created a diagram of what happens within our application. So this is the app talking to its inner workings. The application makes the connection to the database. Then it checks for the global cache whether we already have an existing connection. If there is an existing connection, it returns it and we have the MongoDB instance. But if we're working on a new connection, then it establishes it, connects it, returns it, stores it in the cache so that the next time we can easily retrieve it. The time it would take to review this PR is about 30 minutes, but thanks to CodeRabbit, we didn't have to spend a second. And just like that, our rabbit now hops through MongoDB with glee. Events and models now stored with key. This is absolutely perfect. There are a couple of nitpick comments, and let's see whether CodeRabbit actually caught some issues. It seems like there's a major potential issue. Prevent duplicate bookings per event ID or email with a unique compound index. So what is this actually saying? Well, right now we're doing pretty good work because our schema has indexes that help us make our database queries faster. For example, one for finding bookings by event ID, another one for finding bookings based on the creation date, and another one for finding bookings by email. That's all about speed, not rules. So what CodeRabbit is suggesting is that we add one more index that's unique, meaning the database will enforce a rule that no one can book the same event twice using the same email. This means that the database itself will automatically block duplicates. So you can now very easily just commit the suggestion by checking whether it's okay, but of course carefully review this code before committing. It looks good to me, so I'll go ahead and commit it and implement this update. There's another major suggestion, this time not a potential issue, but a refactor suggestion. And right now, our code is checking if MongoDB URI exists as soon as the file is imported. That means that if someone imports this file anywhere, even if the part of the app that doesn't actually connect to the database, it'll immediately throw an error if the environment variable isn't set. So what CodeRabbit is saying is that when you throw errors at import time, It can crash tools that just load your code without needing to run the database, like a build process or some tests. So the fix is to simply move this check inside of the connect to DB function right before you actually connect. That way, we're only validating the environment when the app is actually trying to connect to MongoDB. In this case, we don't get the auto commit suggestion, but there is another thing we get, and that is prompt for an AI to implement this feature. I'll go ahead and copy it, head back over to WebStorm, check out over to database, models, branch, and run pull just to be safe. Now that we're in here, I'll open up Junie and I'll paste this command that CodeRabbit gave me. And there we go. Very quickly it implemented it. So now if you head over to mongodb.ts, you can see that it is checking for the variable just here within the connect to database function. Perfect. We can now push this change by running git add dot git commit dash implement CodeRabbit suggestion. Or you know what? Why would we let CodeRabbit to take the praise? Let's just say make a check for the environment only if we need to use it. Perfect. And we can push it. With that, this suggestion from CodeRabbit will be resolved, which means that we are ready to merge it. So just go ahead and click merge pull request, and then back within our application, check out back to main, run pull to make sure that we have all the latest changes, and then check out over to and create a new branch for the feature that we'll implement next. Now that our database models are in place, we are ready to create the API routes needed to create the actual events within the database. So call it API routes. Exciting stuff coming up. In this lesson, I'll teach you how to create your first Next.js API route. You can think of API routes as a solution to build public APIs with Next.js, essentially backend applications. So any file you put inside of the API folder will automatically be treated as an API endpoint instead of a page. They are server-side only bundles and won't increase your client side. It looks and feels something like this. API hello.ts. We import some Next API requests and responses from Next, define how our data will look like, and just as you're within your backend or Express application, you can automatically return responses from your API. That's pretty cool. So let's do it together. Specifically within our application, we'll use an API route to create events and fetch them from the database. We could use server actions for these, but to give you a taste of all the Next.js features, I'm going to show you how to implement it using API routes. So let's follow the documentation and create our first API route within app API. Let's create another folder within it called events. And within events, we can create a new file called route.ts. We can immediately start by exporting an asynchronous function, which is going to be called just post, as in a post request. It'll accept a request of a type next request, and we can open up a try and catch block. In the catch, I will simply console that error that might happen, and I will also return a next response. So this is how you actually send data back from your API through a next response.json command, where we can say that the message is something like event creation failed. Actual error will be set to. Now we can check if error or E is an instance of error. Then we know that it'll have the message attached to it. So I'll say error or e.message. Else we can say unknown. So we're trying to be as precise as possible when we can be. So if an error is an instance of error, then we render an error message, else we render unknown. And now we are ready to get started with the try part of the block. First things first, we need to connect to our database. Thankfully, we have already created a function that does just that. So I'll say await connect db, or you can check out how your function is called right here within your MongoDB.ts file. Once we're collected, we want to get access to the form data that we're going to pass into this request by saying const form data is equal to await, and we get access to it through, in Express, it will be rec.body, but here in Next.js, it is rec.formData. Then we want to parse that form data. So I'll say let event and just define it like this. Then I'll open up another small try and catch block, inside of which I'll set the event to object dot from entries. So we'll get all of the entries, such as key and value pairs, from form data, and we'll grab them like this. That way we're putting it into an object. But if something goes wrong with that, we'll return a next response.json with a message of invalid JSON data format. And as the second parameter, you can also attach additional options, such as a status of 400. I also forgot to attach a status right here. This is going to be an unknown server error, so something like 500. But if we properly parse the form data from form data into an object, then we can work with it. So we can create the event in the database by saying const created event is equal to await event coming from database. So we have to import it by saying import event from add database /event.model. And then we can create it by calling the create method on it, and we'll pass over the event data. Once we've created the event, we'll then return the next response.json with a message of event created successfully, and I'll pass in the actual event data set to created event. Here I have a typo. Thankfully, WebStorm caught that for me, so we can automatically fix it. And I'll also attach a status of a 201 to it. 201 stands for created. Believe it or not, this is it. Your Next.js app joined the modern times, came out of the closet, and transitioned from front-end to full stack. We can now make requests to our Next.js API. The easiest way to do that would be through some kind of an API client, like Postman, or in recent times, I've been using more of this HTTPy. You can head over to httpy.io and simply download it. It's great for making simple API requests. Within it, we can try to make the post request to our application by selecting the type of the request to be post, and then typing in 3000 /API /events. Now, we need to pass in some of the body details in a form format. So here we have to fill it in with all the right data that our app expects. I'll just go ahead and turn this into a text format and paste it right here. I prepared an example event that we can pass in. So just so you don't have to type all of this by hand, I'll also provide it to you within the video kit down below, so you can copy and paste it right here. Now, one thing I want to mention is that we're using a pre-uploaded image right here for simplicity. So if you simply head over to this Unsplash URL, you'll be able to see an image of an existing conference that we haven't uploaded to any kind of an image storage solution. And that's not good, but don't worry, we'll fix that soon. For now, I just want to test whether we can actually speak to our Next.js API and whether it can speak to our database and create this new event for us. So I'll go ahead and click send. And it looks like we got a 500. Something's definitely not right. If we head back over to our terminal, we might see some more info as to why this error happened. And before I even open it up, it seems like I know where it's coming from. It cannot find this event model, and the terminal confirms it. So are we importing it properly? It should be coming from database event model TS. We are generating a schema right here, and then from it, we are exporting the event. So it looks like I just missed a /. If we add it, the path will be correct, and we can retry our request. So let's make it one more time. And this time we got a different error message, which I guess is good. Whenever you get a different error message, that means that you're making progress. This time we got an error directly from our application indicating that our content type was not a multi-part form data. Rather, it was JSON. Now, I decided to use form data because we are also going to have image uploads very soon, and form data is better suited for that. You cannot upload an image through a JSON file, right? So we have to switch this over to form, and then we'll have to add fields one by one. Starting with the title, we can copy some of the parts that we had right here in the JSON form. So it's going to be Cloud Next 2026, and then we have to switch it over to here. Moving over, we have the description. Actually, let's type out all the key names so we can then add values later on. We also have the overview. Then there's the image. There's also the venue, location, date, time, mode, audience, agenda, organizer, and the tags. So now let's slowly start copying all of these values, such as the description, over from JSON to the form, and you can do the same thing for all of the other fields. I'll skip the part where I do it. And there we go. I'm pasting the last property. Finally, it's all here in form data. So let's go ahead and remove this JSON body, and instead we'll be sending the form data as the request body. Let's go ahead and send it. And this time we're getting stronger validation. So the error changed again, and the mode must be either offline, online, or hybrid. In this case, I'll set it to just hybrid. Finally, we got a 201 created. Event created successfully, and then we got back the full event data coming from the database. You can know it's coming from the database because it has the created at and updated at fields, as well as the slug, and most importantly, the underscore ID. If you truly want to verify that this event got added to our database, you can head over to MongoDB Atlas under Clusters, Browse Collections, and there's going to be a test database with an events collection name where you'll be able to load your created event. Congrats! You know what this means? It means you've successfully created a Next.js API endpoint that accepts the body through form data, connects to and talks with our database, creates an event, and finally gives back the response. But as you know, so far throughout this build, I've introduced you to all the production-ready tools. And now we'll bring this feature up another level to allow us to upload and store our own images and not just using the images hosted on the web. So let's do that next. I promise that throughout this course, I'll try to use as many production-ready applications as possible to teach you how to use them in your upcoming Next.js applications. So I couldn't think of a better one for image and file upload than Cloudinary. So click the link down in the description and sign up for free. You can sign up with email or choose a provider, and you might need to go over the onboarding process. Once you complete it, you'll be redirected to the dashboard. And within the dashboard, you can head over to the settings right here at the bottom left of the screen. Then head over to Upload, and finally add Upload Preset. You can name the preset anything you like, such as Next.js Crash Course, but make sure to select Unsigned as the signing mode. This will allow you to upload directly from the browser or the embedded widget. You can also specify where the uploaded pictures are going to be stored. Right here, you can store them within the Events Assets folder. The rest of the settings can remain as they are, so just click Save. Once you've done that, head over to API Keys and copy this API environment variable. Then within your application, you can head over to the .env file and just paste it. You'll have to switch the template right here with the actual API key and secret. So go ahead and generate a new API key. You'll have to enter the email confirmation code, and then you'll be able to see it right here. I'll use this new one. You can see I was using Cloudinary back in 2022. So I'll go ahead and use this new API key, modify the key right here, and then do the same thing for the secret. Now, there's also another thing we need to do to be able to load images coming from Cloudinary, And that is to head over into our next config, and right here at the top, say images, define an object where we can define the remote patterns of images, and then within an array, add another object with a protocol of HTTPS and a host name. In this case, host name will be res.cloudinary.com because that's where the Cloudinary images are going to be stored. This will just allow us to actually load them in. Finally, within our app, you can just run npm install Cloudinary, and now we are ready to get started with implementing the image upload feature. Back within our route, right here, API events route, right here after we form the general event data, but before we actually generate it, we want to be able to get the uploaded file. So I'll say const file is equal to form data dot get image. That's where it's coming from. And I'll define it as a type of file. Then if a file doesn't exist, we can just return next response .json with a message of something along the lines of image file is required. And then we can also give a status of 400. But if we do have a file, in that case, we can convert that file into a buffer. So I'll say const array buffer is equal to await file dot array buffer. This returns a promise that'll contain a copy of the blob data. Typically, when we work with files, we want to get access to the blob. So say const buffer is equal to buffer dot from array buffer. And now we can use that to pass it over to Cloudinary and to actually upload it. To do that, I'll say const upload result is equal to await new promise, where we get the callback function with resolve and reject functions. And here we want to use the Cloudinary object, which we can import at the top by saying import v2 as Cloudinary coming from Cloudinary, which is the package we just installed. I'll put it at the top as that is an external dependency. And then to upload it, you can type cloudinary.uploader.upload_stream. To it, you can pass an object with some info, such as the resource_type set to image, as well as the folder where you want to save it, which I'll set to dev event, the name of our application. Then as the second parameter, you can pass the callback function of the upload. If it fails, it'll give us the error. And if it succeeds, it'll give us the result. And here we can open up a new function block where we can say if there's an error, we can simply reject from this function using the error itself. And if it succeeds, we can simply resolve the results. And then here you can say .end buffer. I pulled this directly from Cloudinary docs. Now this upload result will contain the URL to the image uploaded on Cloudinary servers. So we can say event.image. So we're adding it to the actual event data, this one right here. And we can set it to upload result dot secure URL. Now, TypeScript isn't sure that upload result contains the secure URL. So we have to wrap it in parentheses and define it as an object that actually has a secure URL of a type string attached to it. That way, it'll not complain. And just like that, we have added this image to the event, but this time the real image that we uploaded and that actually got hosted on Cloudinary servers, and we're passing it over to our database so it gets created. Now, if you still have HTTPy opened with all the fields that we sent before, we can retry it, but now making a request with an actual image that we're uploading. So instead of this image right here as a text, we can pass over a new image property, but now upload a file. So I'll head over to our application and get the event that seems the most fun. Let me go with this one right here. I'll save this image to downloads. And then back over here, I'll just upload it. I selected it, and you can see that it is right here. So now we can try to create a new event, but this time with the image that we have uploaded to the form. I'll click send, and this time it says event creation failed, duplicate key. Oh, that's good, because the slug is the same, and it nicely figured it out. This might actually be that fix that CodeRabbit provided to us. So I'm super glad this happened. I definitely want to change the name. Maybe we're going to go with Cloud Next 2027. So let's go ahead and create it. And there we go. Event created successfully, Cloud Next 2027. This time, if you take a look at the image property, you'll see that it is an image hosted on Cloudinary. So you can copy the URL, and if you search for it, it'll actually open it up. So back on Cloudinary, if you head over to Assets, Folders, Dev Event, you'll be able to see this image that we just uploaded. Now, back within our application, we want to create a GET request to fetch all the events from the database. That's going to be even simpler than creating this POST request. We can just collapse it and create a new function just below by saying export async function get. This one will have a try and catch block. In the catch, we'll do something similar to before. We'll just return a next response.json where the message will be set to event fetching failed. And we can also display the error. And finally, I'll pass over the status of 500, server error. But in the try, we can actually try to fetch this image by trying to connect to our database first, so connect DB, and then we can get the events by saying await event.find, and we can also sort it by created at -1, which means that the new events will be shown at the top. And now we can just return next response, that JSON event list successfully, or we can say something like events fetched successfully, and then pass over the events with a status of 200. I told you it's going to be simple. This is your second server API route. Now we can make that request within our HTTP by switching this over to a GET request and then just heading over to the same route. The HTTP verb is different, but the endpoint is the same. So if you just retry the request, you'll see events fetched successfully, and then you'll be able to see your two events that we created. One containing the image where we didn't have the file upload implemented, and the other one with our own uploaded image. You can also try to make a request within the browser, because by default, browsers are making GET requests. So if you search for localhost 3000/API/events, you'll see that you'll get back the JSON data. This means that your Next.js application is also acting as, right now, very simple, but with possibility of becoming a very powerful backend API. But this isn't what you want to display to the users. You want to get the data in a nice format and then display it on the front end. That's the beauty of Next.js applications. Next.js is essentially replacing the need for a typical MERN stack, MongoDB, Express, React, and Node, because here Next.js handles all the pieces. So in the next lesson, let's figure out how we can actually call this API route from the front-end side. In this lesson, you'll learn how to use the created API routes on front-end and then display the data you're getting back from these API routes. Now, before we call this API, let me show you one thing that'll make it easier for us in the future. Head over into your .env file and add a new variable, next public base URL. Notice how this one starts with next public, and so do these two from PostHog. In Next.js, the next public prefix means that this environment variable will be accessible on the client side as well as the server side. Whereas if you don't put the next public here, it'll only be accessible on server side because it has to be a bit more secure, such as the MongoDB URI that has everything to do with managing our database, or Cloudinary URL for managing our images. But for some variables that don't contain any very strict keys, it is okay for them to be available on the client side. Maybe they have to be executed on the client for them to be able to work. So specifically, what is this base URL? Well, for now, I'll set it to http localhost 3000. And then later on, after we deploy the application, this will be replaced by the production URL. Now that we have it, head over to our page, and here we'll call the get API route to get all the events created so far. We can do that right here at the top, and you can start by making this a page asynchronous. Yep, in newer versions of Next.js, server pages can be made completely asynchronous, allowing you to have top-level await. So here you can say a response and make it equal to the await fetch of, and now you can either manually type localhost 3000, or you can just use the base URL from environment variables, which will make this code work right here, right now, but also it'll work on production. Whereas if you hard-coded localhost 3000 right here, this would break in production because later on, maybe you have something like jsmastery.com/events. So what you can do is get access to this environment variable. I'll call it base URL, and we'll get it from process.env.baseURL. And here it'll start with base URL /API/events. Then we need to destructure the actual events from the data by saying events is equal to await response.json. Now we no longer have to import these events coming from constants. Rather, we're already getting them right here from our API. Now, right here, we're mapping over them, but it looks like this event doesn't know of which type it is. So I'll say that this event is of a type I event, which stands for interface event, containing all this data of exactly how this document looks like in the database. And we can also add one more check, and that is to check whether events exist, and if they do exist, whether the events.length is greater than 0. Only if those two conditions are met, then we can start mapping over them. Now, if you try to run your application, you'll see that there's going to be an error here saying that it cannot find this base URL. And that's because I missed adding next public base URL in order to be able to load it. That's the real environment variable name. So if we use that one, you'll see that then it'll work, or for you, it won't work yet. It'll say that it cannot load an image from Unsplash. I already deleted it, so it's working for me. But if you want to immediately make it work for you as well, head over to your MongoDB Data Explorer under your cluster, find the event that has the image of Unsplash, and then delete it entirely. And just leave the one that has the event with their own uploaded image. If you do that, you should be able to load the homepage properly. In a similar way to creating this get API route, you can also create another API route to fetch a single event by its slug or ID. And since SEO is a priority for this project, a URL, something like /event/Next.js-conf 2025 is much more user-friendly and much better than a URL that looks something like this with a random ID. Small details like this significantly improve discoverability, so when someone searches for Next.config 2025, your site has a better chance of ranking higher. So we'll proceed with this slug approach and build that route. But this time, since we have already built this get route, I want you to think about how you would implement the get route for fetching a single event. Once you do the thinking, we can let AI do the heavy lifting. So to make it 100% clear, we need a route that accepts a slug as input, and then it returns the event details. And it can also respond with an error message if the event isn't found or if something goes wrong. That's it. So now we can let AI do the work while you focus on more important aspects of your application. That's how web development is going to look like in the next decade. And you're getting to learn that right here in each one of my videos. So head back over to Warp, and then in the video kit down below, you can find another copyable snippet containing the AI command for this feature. You're a backend developer working on a Next.js app, This time, we need to create a get API route under app API events slug route.ts. I'll soon explain this naming structure that we're using right here that returns event details by slug. And then here, I was just a bit more precise to make sure that both of us get the same input. So now you can press enter and let it generate this code for you. There we go. It is done. So I'll go ahead and accept it. That is perfect. Warp just implemented this new dynamic API route with complete slug validation, sanitization, database querying using Mongoose with lean method for better performance, for handling, error handling, and type safe implementation. This is exactly what we wanted. So back within our application, let's see this newly created file under events, slug, route.ts. Now, why are we using this naming convention? Why did we have to create another folder with square brackets and then put this route file within it? Well, that's because within square brackets, you put dynamic parameters. Our URL is going to look something like this: /events, which is static. You can see that because it doesn't have any square brackets, and then some kind of a slug, not an ID like this, but rather Next.js conf 15, right? And this part right here, you want to be able to get within your application. So Next.js will automatically take this data and put it into a slug variable because it is expecting one based off of this folder name. So now let's go through this implemented route together. First, we're defining some route params, and then we have this API event slug, which fetches a single event by its slug. First, we have a request of a type next request, and then right here, we have the route params, which when destructured contain the slug. So as usual, we're first connecting to the database, then we're waiting and extracting the slug from params. So one more time, as a second parameter to the get request, you're getting the route params. You can destructure it, and then you get whatever the variable name is. If you name the folder something like ID, then here you would be able to destructure the ID and get it directly within your code. In this case, we called it slug, so we get a slug variable. We're doing some slug validation to check whether it's actually okay. So we're sanitizing it, like trimming it and lowercasing it, so we can make sure that it works nicely in a URL. Again, this is just the extra work that I maybe would not have done immediately, or would not have remembered, or would not have had the time to implement it this way. But this is truly how it should be done. So we humans love to cut corners sometimes, but AI doesn't do it if you instruct it well. And finally, we're querying the event by slug. So we're saying event is equal to await event.find1, and we find it by a slug. Then if no event is found, we simply return an error message, but if it is found, then we return the fetched error successfully. Finally, in the catch part, we're sending some errors, like a 500 if we cannot find the MongoDB instance, or another 500 if an unexpected error happened. So now we have another API request, this time to get the details of a specific event. And if you want to learn how to build super secure production-grade API routes, complete with robust validation and global error handling, with even custom logging to figure out what is happening and what could go wrong, definitely check out the Ultimate Next.js course. You can see that I'm just scrolling through how many active lessons there are and through how many API routes we're creating here. We're diving deep into route handlers, common API things to keep in mind, the typical routes as well as the dynamic routes, and creating reusable API fetch handlers. But with that said, we can now easily fetch the details of one of these events that we have right here based off of its slug. So we can test it in this API client. I'll go ahead and copy the slug, Cloud Next 2027, at least that is the case for me. So I'll head over to API events, Cloud Next 2027, and make a GET request, and we indeed do get the details of that event only. The next step is to use this API route on the front-end side of our application, so we can make use of the content and display it on the UI as it's shown right here within Figma. We can do that by creating a new file for this page. Since Next.js uses file-based routing, I'll create a new folder and call it event. And then within event, I'll create another folder with a dynamic route called slug. And then within slug, I'll create a new page.tsx. Here we can run rafce, and we're exporting this new event details page. So I'll rename it to event details page. And now I'll put my browser side by side with my editor again so we can see what's happening. Looks like for a long time I've had this error saying fail to parse URL from undefined API events. So if you head over to our homepage, that's where we're seeing this event. It looks like base URL is set to undefined. But why is that the case if we are setting it as the localhost 3000 right here? Well, that's because I should have used the full env name next public base URL like this. And then here we can use its variable name. So if we do it like this, you'll see that it'll work. But then we have another error saying that images unsplash is not configured under next config. Remember that for one of those events, we use an image that is already hosted somewhere. So what you can do is head over to next config and add unsplash right here as another image host that we support. Or you can just head over to your MongoDB Atlas under collections, find the event that has this image that we haven't uploaded and delete it. Because from now on, all of our images are going to be hosted on Cloudinary. So now if you get back and reload, you'll see that now we're fetching a real event from our database and it's actually getting displayed. So if you try clicking on it, you'll be redirected to a 404 because right now it is pointing over to, let's figure out where. In the event card, it looks like the link is going to events slug. And here I called it event. When it comes to the naming convention, when you're naming API routes or endpoints, it is always good for the collection of the elements, such as event, to be plural. So this right here is correct, whereas the name of the folder is incorrect. I'll rename it to contain the plural form, events, so that a single event within it is denoted by a slug. So now if you click over on this event, you'll be redirected to a new page, which is this event details page. Now, so far, this is just a static page that says page, but how do we actually figure out which event this is? So this is the event with the following slug. Well, we can do that by extracting it from the params. I'll first turn this function into an asynchronous function and then destructure the params, and I'll specify that the params are of a type promise, specifically a promise that'll be resolved with an object that contains a key of slug of a type string. So now at the top of your page, you can simply say const and then destructure the slug from the params, but make sure to await it. To be able to extract the value, you have to add the await keyword. Now you can say return a section with an ID of event, and then within it, you can render an H1. This time, you can say event details of an event with the following slug. There we go. Event details, Cloud Next 2027. This means that this page right here is a dynamic page loading this slug from the URL. But now we have to make a GET request to this new API route we created, which is under API events slug route, that'll fetch all the necessary details so we can actually render it and display it properly on that details page. So let's call it by saying const request is equal to await fetch. We can once again get that base URL at the top, but not make the same mistake that we made before. I'll say base URL and make it equal to process.env, and it'll be next public base URL. So we can make a fetch request to base URL /API /events /slug. Then from here, we should be able to extract the data, and that's going to be equal to await request.json. If data is not found, we can simply return a not found method, which is given to us by next navigation. So we're automatically redirecting to a 404. And that seems to be the case. If we click on it, we're automatically redirected. So why isn't this fetch request giving us the actual data? Well, if we head over into this events slug route, you'll see that we are returning from it right here as message and then the event. So event is the name of the data, not data. So we can destructure event like this. If you do it like that, you'll see that now you won't be redirected because now the event data is actually there. Perfect. This was a good one. In the next lesson, let's make this page go from this to this. We'll fetch the full title, summary, and overview, as well as the event details and the complete agenda, some info about the organizer, and the tags. We can also render a form to book it. So let's do that next. In this lesson, we'll implement the UI of the event details page and display the data that we've been working so hard to get from the API. Looking at the Figma design, the event details page will need different elements, from these little pills for the event tags, front-end, back-end, AI, open source, and so on, the event sign-up card, and for the similar events, we can reuse the event card from the homepage. So let's develop it. I'll start with a header by creating a new div that'll have a class name equal to header. Within it, we can display an H1 that says event description. And just below it, another P tag that'll display the event description, like this. Event description, Google's premier cloud computing event. Now, if you don't want to repeat event every now and then we can immediately destructure all the data from that event, such as the description. And what else do we have on it? We also have the image, the overview, the date, time, location, mode, agenda. Let's remember what else do we have in there. It's the audience that is a good fit for this event. And finally, the tags. So now we're destructuring all of this. So we have to check whether the event that, well, let's say description, for example, exists. And now it's going to be just description. So if there's no description, that must mean that there's no event as well. And we can just display the description. Perfect. I'll give this p tag a class name of margin top of 2 to divide it a bit from the title. And then below this div, we can create another div that'll have the class name of details. We will split this div into two parts. One will be for the left side, which is the event content. And then the right side will be for the booking form. So I'll call it booking form. For now, for the right side, we can just say aside with a class name of booking. And then we can display a p tag that says book event. That'll have a class name of text-lg and font-semi-bold. For now, on mobile devices, it appears right here on the left side. But if you add something here on the left side, like a div that has a class name equal to content, and within it, you display an image with a source of, let's do image, and an alt tag of event banner that has a width of about 800, as well as a height of 800, and a class name equal to banner. If you do it like that, you'll see this big image appear, and then later on, we'll make this book event appear on the right side so it fits the design. But for now, let's focus on the main content. So below this image, I'll display another section. This section will have a class name set to flex-call-gap2 to create some spacing in between the elements of this column. I'll create an H2 within it that'll say overview. And then below this H2, I'll create a p tag that'll simply render the overview we're getting from the database. Then below this section, we can create another section. It'll also have a flex gap of 2. And this time, we'll render the details. So I'll say H2, event details. And now here, we'll have to render all of these different little icons. One will display the date, another one the time, and so on. So we'll create this as a reusable component that we can easily call. We can do that by creating a new small component right on top of this one. And I'll call it event detail item. It'll be a React functional component with an immediate return. As the props, we'll pass in the icon, the alt tag, and the label for the icon. We also need to define the types of these three props. All of them will be strings. So I'll say icon is a string, alt is a string, and the label is a string as well. And then for each one, we can just return a div, within which we'll render the image. That will display the icon, the alt tag, with a width of about 17 pixels, height also 17. And then below it, we can display a p tag that'll render the label. So now we can use this new component right here below the event details. I'll use it by simply calling this reusable component of event detail item, and I'll pass the right icon to it. So that's going to be /icons /calendar .svg with an alt tag of calendar and a label of, it's going to be the date. So now if you save it, you can see how it looks like right here. We also want to attach some class names to this div, wrapping this image and the p tag. And I'll give it a class name of flex-row-gap2, as well as items-center. When you add these class names, it'll look much better, just like this. And I don't think I even need this margin top right now. Perfect. This is good. So now if we scroll down, we can now duplicate this event detail item a couple of times for the time, the location, mode, and the audience. I think that's 4 more times. The second one, I will rename to clock, and it'll actually render the time. Then the next one, I will rename to pin, as in location, and this one will render the location. After that, we have the mode. So I will render this one and call it mode. The label will be mode as well. And finally, for the last one, I'll go with audience. So now if you save it, very quickly we get all of these different icons. Of course, if we properly spell clock, it'll look even better. Now below this section, we can render the event agenda. For the agenda, I'll also create a new reusable component right at the top by saying const event agenda, which will accept an array of agenda items. So I'll define the type of the agenda items to be an array of strings. And then we can automatically return a div that'll have a class name equal to agenda. It'll have an h2 that says, well, agenda, and then a UL, an unordered list, which will map over all of the agenda items. And for each one, it'll return a list item that has a key equal to item, and it'll simply display what that item says. So let's fix this spelling right here, event agenda, and let's just render it as a component right here below the section. I'll render a self-closing event agenda component, and under agenda items, I'll pass over json.parse. We have to parse the data as it's coming stringified. We'll pass over the agenda and then the first property from it. And now you can see exactly what is happening throughout this event. Now below that, we'll render some information about the organizer. So I'll render a section with a class name of flex-call gap2. It'll have an h2 that'll say about the organizer. And then below it, we'll render a p tag that'll say organizer. Let's make sure that we have destructured the organizer right here from the event. It doesn't look like we did, so I'll do it right now. And now we'll be able to see more info about Google Cloud. Perfect. Finally, we have to render the tags right here below. So for that, I'll also create another reusable component that we can easily call const event tags, which will accept the tags, which is going to be just an array of strings. And we can immediately return a div with a class name of flex, flex-row, a gap of 1.5, and flex wrap. So they wrap if they cannot fit in one line on smaller devices. Then we'll map over the tags, and for each tag, I'll return a div that'll have a class name equal to pill and a key of tag, and it'll display the tag. So now we can collapse it, and we can call these event tags right here below the section where we talk about the organizer by simply rendering event tags. To it, as the tags, I'll pass over json.parse tags 0 to get the first part of the tags, and we'll just render it. And you have cloud, DevOps, Kubernetes, and AI, which are specific tags for this specific event. Now, if you expand this UI, you'll see that it looks good. It looks great actually on desktop, but there's something missing. This book event functionality on the right side is pretty empty. And that's where all this light is shining anyway. And of course, the main point of the app is to be able to book an event. But before we go ahead and implement that feature, I want to make sure that what we have developed so far doesn't only look good, but actually doesn't break and follows clean coding practices. I don't want to open up a PR just yet, but thankfully, we can quickly check it using CodeRabbit CLI. You can click the CodeRabbit CLI link down in the description, and you can install it with a single command. You copy it, and you paste it into your terminal. Once that is done, you can restart your shell, or simply run source zshrc or whatever your command says. And then after that, you can run CodeRabbit auth login to authenticate. This will authenticate you with your account. So you can copy the token and then paste it into your terminal. Now that we've authenticated, I will expand my terminal and give it some more room. And I will simply run CodeRabbit. This will open it up right here. And to dive into the review, you just have to press enter. And now we're channeling the spirit of senior developers. And the AI is pretending that it knows better than you. So let's see what it actually comes up with as it's analyzing your code. You can keep reading these messages. Pretty cool way to pass some time as it's analyzing the code. Given how it's messing with us, it better be good. Thankfully, it doesn't look like we have any code issues with our event details page, just some grammatical errors in the comment and error messages. It's pretty cool how we didn't even write this comment right here. It was written by AI, and it looks like AI messed up on the grammar right here. So it's suggesting us to fix it. We can fix it very easily by using an AI prompt, or we can make the change ourselves. But as I was reviewing this, it also provided some additional changes that we can make, such as validate the base URL to prevent the runtime errors, or add some additional error handling for our API fetch. This is actually a great suggestion. Oh, looks like we do have some potential issues on the events details page as well. One is validating the base URL, some more to add error handling to JSON parse to prevent crashes, and then adding some comprehensive error handling for data fetching. These are all great suggestions, which you can now apply with a single key press. It says A to apply the suggestion. So if I press the letter A, and then head back over here, you can notice that it automatically applied the changes right here. So when we're fetching the event, it's actually adding this try and catch block to make sure that everything goes right. And if it doesn't, it'll properly fetch it and let us know. So feel free to apply as many of these as you want. For now, I'll just exit it. Back within our event details page, we still have to do the right side, which is the booking form. So let's go ahead and create a new component for it. Right here within the components folder, create a new file and call it book event.tsx. Run RAFCE to quickly spin it up. And then back over within this component, Instead of this p tag, I will render a div that has a class name set to signup card. Within it, it'll render an h2 that says book your spot. And then we'll check if anybody else booked this event before us. We can do that for now by creating a new variable right here, const bookings, and I'll set it to 10. And then we can say if bookings is greater than 0, in that case, we can render a p tag with a class name of text-sm, and we'll say join bookings people who have already booked their spot. Else, if booking is equal to 0, in that case, we'll render a p tag with a class name of text-sm, and we'll simply say be the first to book your spot. And then below it, we want to render the book event form. So if you do this and collapse your IDE a bit, you should be able to see it here, book event, and here it is. Of course, on larger devices, it is actually appearing on the top right side. So I think we can even keep developing it like this, enlarged just to the point where we can still see it on the screen, and we can develop that component. Let's start with a div that has an ID set to book event, and we want to figure out whether this current user has already submitted their email to join this event. So we'll need to use two different use state fields. The first one will be their email, of course, which at the start will be equal to an empty string. And then the second one will be if they have submitted their email already, which will at the start be set to false. Now, since we're using hooks, we automatically need to turn this into a client component. So at the top, I'll add use client, and you can see that it works. And now if we have already submitted, so if submitted is true, we can just render a p tag with a class name of text-sm and say, thank you for signing up. But if we haven't submitted already, we then want to render a form within which we'll render a div, within which there's going to be a label with an HTML for the email field, and it'll say email address. And below it, I'll render an input with a type of email, a value of email coming from the state. On change, we will simply call set email target value. I'll put all of these into new lines so you can see them better. And then we'll also give it an ID set to email, as well as a placeholder of enter your email address. And now we can see this input appear right below. Finally, below it, below this div containing both the label and the input, we can render a button with a type submit and a class name equal to button-submit. Within it, we can simply say submit. That'll now look something like this. Perfect. Now, what are we actually submitting? Well, we want to create a new callback function called handle submit that'll take in the event of a type react.form event, and it'll do something. We'll actually call this function once this form is submitted. So we want to say on submit, call handle submit right here on this form. Then, once we're handling the submit, we can simply run e.prevent_default to prevent the default behavior of the browser to reload. In React and Next.js applications, you don't want to have that reload happening. And then what else can we do? Well, for now, I'll set the timeout and then within it a callback function for about 1 second where I'll set the submitted to true. So once we submit it, like let's say I'm joining with contact@jsmastery.com and I click submit, it'll say, thank you for signing up. Later on, we can hook this up to the actual functionality of booking this event to actually be able to join and participate. But with that in mind, Amazing job for developing this event details page where we can see all the information about this event. And not only are we rendering the UI, but you've also done a great job of fetching this dynamic parameter of slug. And then based off of that slug, you're now fetching that event directly from our API right here with an API events slug route.ts, which returns the details of this specific event. Great work. And in the next lesson, we'll learn more about server actions. They're like API Route's younger brother, a bit smaller and faster, but still super powerful. So let's dive into that next. Up to this point, you've learned how to create and fetch the API routes from the frontend. But there's another powerful Next.js features that we haven't talked about yet. It's the server actions. So what is a server action anyway? They're simple functions that are asynchronous and are executed on the server. You can trigger them directly from the client side, for example, during a form submission, to securely handle mutations, side effects, or any other server-side logic without exposing sensitive code. Essentially, they allow you to make a post request straight to the server, minus all the boilerplate code that you typically would have to write when writing API routes. The only thing you have to do to make something a server action is to add the use server directive. You can either add it at the top of the function or at the top of the file that then uses multiple server actions. So let's create our first server action and see how it's different from the API routes we've created so far. Head over into your lib folder right here, and then create another folder within it called actions. Within actions, create a file for your first action and call it event.actions.ts. Here, we'll implement a function that returns similar events by a slug. So first things first, as we discussed, you have to add a use server directive at the top. That means that all the code within this file will be executed on the server, not exposing any important info. Then we can export and create a new function, get similar events by slug. It'll be an asynchronous function that accepts a slug of a type string, and it simply opens up a function block. I'll open up a try and catch block. In the catch, I'll simply return an empty array because we weren't able to fetch any similar events. But in the try, I'll first try to connect to the database, same as what we've done within our API endpoint. And then I'll simply try to fetch all the events by saying const event is equal to await event dot find one, and we'll find it based off of a slug. But first we have to import event right here at the top by saying import event coming from /database/event.model. And then once we find the event we're looking for, we can find all the similar events for that event by making another await event.find call. But this time we'll say _ID must not be equal to the ID of the event we found above. So we don't want to show a similar event that is the same as the event we're showing similar events for. So that's the first thing. And the second thing is, how are we going to know which events are similar? Well, by tags. So I'll say if $in as in included specific event.tags. So if this event that we're searching for includes any tags that the original event has, then they must be similar. And finally, we'll return all the similar events. You can see that WebStorm even tells me that this local variable is redundant because we can immediately just return these similar events, and that allows us to make it even simpler. So let me ask you, just how simple and straightforward is this? You can focus purely on the core business logic of your application, in this case, getting similar events by slug, without having to worry about requests, responses, or any extra setup. It feels just like writing plain JavaScript, but on the server side. Remember when you created an API route to create an event? That is right here under API route.ts. Well, first of all, you needed a new file following this file naming convention for API endpoints. Then you had to define this special post function that has this special request and responses. And then you had to use this next response to be able to send back the data. I mean, it's not that difficult, and AI helped us with validations and error handling, but there was still a lot of boilerplate, like defining the route and using the next responses.json to send over the data. And then, not only that, when you actually called some of these routes, you then have to make a fetch request to be able to load in the data from that API. But with server actions, all that goes away. You just write a regular JavaScript function with your server-side logic and call it anywhere in the app, just like calling any other function. Too good to be true, right? But let me show you. We can now use the server action within our event details page. So head over to event slug page, and then right at the bottom of this page, I'll say const similar events, which is going to be of a type iEvent array. So it's going to be an array of events, is equal to await get similar events by slug, and we'll pass in the slug. It cannot be any simpler. No need to even make a fetch request. And just like that, right below at the bottom of this page, where we have this div and aside, and then another div, below all of it, still within the section, I'll create a div with a class name equal to flex, wfull, flex-call, gap of 4 in between these events, and a padding top of 20 to give it some space. I'll render an h2 that'll say similar events, and within it, I'll render a div with a class name of events. And finally, we can now check whether similar events dot length is greater than 0. And if it is, we can then map over similar events by saying similar events dot map. And then for each similar event of a type iEvent, we can automatically return our reusable event card that we created before. And then you can pass all the right properties. In this case, I think we can even spread them out by saying ... similar event like this. And don't forget to give it a key because we're mapping over this element. So that's going to be similar event .id. Now, I promised this would work, right? So if you scroll down, we're expecting to see some similar events, but there are none. That's because our tags aren't stored in the right format. We're using form data, remember? Which means that the array that is being passed over is serialized as string. So currently our tags in a format that looks like this: a string containing an array containing different tags, which is why MongoDB stores it incorrectly. To fix this, you can head over into our API events route.ts, head over to where we're first creating a new event. Right before we upload the file, we can get access to the tags by saying tags are equal to json.parse form data.get tags as string. And tags has to be a string as well, because that's the property we're getting from the form data. In the similar way, we can get the agenda because it's also going to be within a stringified array. So get the agenda by saying form data.get agenda. Now, just before we create a new event with this information detail, we're not going to pass in just the event. We're going to pass in the spreaded properties of the event, so containing everything, but with stringified tags and agenda. But then we're going to override the tags with the new tags and the agenda with the new JSON parsed agenda. So this way, we're storing it in the right format. Now, if you head back over to your API client and you head over to the post request to API events, we need to create at least 2 new events having the same tag, and then that way we'll be able to see similar events. So what I'll do is I'll change the name to something like the Real Cloud Next 2026. This one will have the tags and the agenda in the right format, and I'll upload a different image. You can get the images directly from our code by heading over to public images, and then you can see event 1, 2, 3, 4. You can then open that up in Finder or File Explorer if you're in Windows. You can delete this image right here, and add a new one by simply drag and dropping the other event. Now I'll create this event. I'll change the name to something like the Real Cloud Next 2028, which should be related to this one because it has similar tags. And I'll upload another event image and create it. Now, if you head back over to dev event, you'll be able to see two new events. Oh, looks like we have some kind of a bullet point right here, which we have to fix. So let's do that right away. That should be within our reusable event card. So head over into components, event card, and it doesn't look like it's here, but if we head over to where we're displaying those reusable cards, that's going to be within the homepage. We have an li here and the ul. We can give it a class name of list none, which will remove those list item dots right here above each one of these cards. Now we can see two new events. The real events are the ones with fixed agendas and tags. So if you click on it, you'll see that as you try to open it, it'll now break because we're trying to parse what is already an object. So this JSON parse was just a quick fix until we get the data in the right format. So back within the details page, we'll have to stop parsing the agenda and the tags and just display the tag and the data itself because it's already coming in the right format. So you can say agenda and tags without getting the first element. If you do that, you'll notice that it'll now work, even though this image is a bit too low res for what we're trying to do here, but you get the idea. We can upload more quality images, and now it's rendering the tags. So if you check out similar events for the Real Cloud Next 2026, we should be able to see it here, but it's still not popping up. So let's try to console log the similar events right here to see what we're getting back. You'll get this console log within the terminal because this page is rendered on the server side. And we can see that similar events is an empty array. That means that we have to head back over to get similar events by slug and check whether our query is correct. And it looks like I made a typo right here. We're first searching for an event whose ID is not equal to this current event ID, but then we need to close this part right here and do another check for the tags. These two have to be separated. With that, our similar events should now actually bring back another similar event with the same tag. So if you get back, you'll be able to see it on the screen, but there are some warnings, such as that we're passing an empty image. Might be due to how we're spreading the data into the similar events. So we're spreading the full event data containing the image and all the other properties. And here we're automatically destructuring them. And I'm actually super glad this error popped up because it's something that is super hard to pinpoint exactly why it's wrong because it feels super right. Like we're just passing over the event, spreading all of its properties, and these properties indeed contain the title, image, and everything else that it needs to render it properly. Similar to what we're doing on the homepage, right? Nothing is different. We're simply spreading the event of the type iEvent. But then why is the event card saying that this image right here is undefined? And all of the other properties for that matter? Well, that's because we're trying to render objects, or what seemingly are objects, returned to us by Mongoose. These are actually Mongoose documents, not regular plain old JavaScript objects. So when you try to spread them, they behave a bit differently. They look like plain objects, but are not exactly the same. So you need to ensure that you're returning the plain JavaScript object from your server function. You can do that by simply adding the .lean at the end of the method. That way, when you do, and when you try to pass over and spread this object, it'll spread properly. And we can pass in the title as the unique identifier. So now if you get back, you'll see one similar event. And if you click on it, it'll lead you to the details page of that event. So with that, our app got so much more functionalities because you can now actually traverse between different events that you like. Perfect. In the next lesson, we'll dive into caching. As your application grows, one of the biggest performance wins you can achieve is through caching. And in Next.js 16, that's easier than ever thanks to the new Use Cache API. On the Next.js 16 update document page, if you search for cache, you'll see that it's mentioned 40 times. Yep, there's so many new stuff regarding cache. So today we'll go over this new use cache directive, which can now be used to cache pages, components, functions, and which leverages the compiler to automatically generate cache keys wherever it's used. What this means for you is that whether it's database queries, API responses, components, or very expensive calculations, use cache will now let you cache results during build time or runtime for a certain customized time, improving speed, reducing load, and keeping your app lightning fast. While Next.js 16 was still in beta, I spent time preparing this little dev event application so we can showcase how caching functionalities work within it. Even though use cache isn't in its experimental stage, you still have to manually enable it within Next config. So whichever Next.js application you're working on, head over into your Next config and right at the top, say cache components and turn this to true. If you hover over it, it'll tell you that when enabled, in development and build, Next.js will automatically cache page-level components and functions for faster builds and rendering. This includes the partial pre-rendering support. And for more info, you can refer to the cache components documentation. That's right here in the latest version of Next.js 16. The cache component flag is a feature in Next.js that causes data fetching operations in the app router to be excluded from pre-renders unless they are explicitly cached. This can be useful for optimizing the performance of dynamic data fetching in server components. It is super useful for when your application requires fresh data fetching during runtime rather than serving from a pre-rendered cache. So what this allows you to do is when you turn on cache components, they can be used together with use cache so that your data fetching happens at runtime by default unless you define specific parts of your application to be cached with use cache at page, function, or component level. Finally, we can make the decision ourselves. So now that we've enabled it, we can use it to cache a whole file, a component, or even just a function result or a network request. Now, depending on your app's functionalities, you might want to turn it on or off within a couple of different components or pages, but I'll show you what we can do within this little demo application. Within the app folder, there's our homepage. And at the top, we are fetching some data from our API route. Now, this is a super common use case. You're fetching some data and displaying it. Now, let's try to cache the result of this API. For example, we can cache it for an hour. The only thing you have to do is turn on the use cache directive right here at the top, and then say cache life. Similar to cache control with a max age, it's a custom time span for how long you want to revalidate the data. You can import it from Next Cache and simply say hours, and you can see that this is one of the default options. You can provide a full config, such as stale, revalidate, expire, or you can just say seconds, minutes, hours, days, weeks, or max. If you head over to another new feature under functions, there's a cache tag. And the cache tag function allows you to tag cache data for on-demand invalidation. By associating tags with cache entries, you can selectively purge or revalidate specific cache entries without affecting other cache data. Finally, this is the level of customizability with caching that we've been waiting for from Next.js for a long time. So first of all, to use the cache tag feature, you have to enable the cache components flag in your Next config, which is what we've just done. And then you can call cache tag, which takes one or more string values, such as my data in this case. You can then purge the cache on demand using revalidate tag API in another function, for example, from a route handler or a server action, which will give you the latest updated data if you need it. A couple of things that are good to know here are idempotent tags, which means applying the same tag multiple times has no additional effect. No need to do that. You can assign multiple tags to a single cache entry by passing multiple string values to cache tag. And there are a couple of limits. The max length is 256 characters, and the max tag items is 128. So here are a couple of examples. For example, tagging components or functions. In this case, we have the bookings data, which we can see right here. You can also use the data returned from an async function to tag the cache entry. So for example, here we're getting the bookings data, and we can cache it just before returning it. Finally, when you need new data, you simply call revalidate tag. Right here, we don't have to do absolutely anything because this component will automatically be cached for hours. And don't forget to open up this component block right here. Now, taking a look at our homepage, it looks like we have 3 posts right here. So if we try to create another one, let's say we want to add an event for 2029, I'll upload some different image and click send. Now, if you reload on our homepage, you'll see that a new event won't be shown, which might seem a bit counterintuitive at first, but that actually means that our caching is working. If you were to check on MongoDB Atlas, you would be able to see this new event there. But even though it is in your database, your network request has been cached for the next hour. That means that you'll still be seeing the stale data, which for the events application where there are no new events happening every couple of seconds is totally okay and actually saves us so much time on traffic and makes the page load faster for all the other users. Of course, what you want to cache, where you want to cache it, and how long you want to cache it for depends on your application's needs. This was just a little demo to show you how use cache works. So if you want to learn use cache in depth and understand how it works on all kinds of levels and how we can integrate it within our Dev Overflow application, I'll cover that soon in a dedicated module of the Ultimate Next.js course. Now that we've implemented caching, I think it might be a good time to open up a PR to review all of our changes and everything we've done so far, starting all the way from implementing API routes. So I'll run git add dot, git commit -m, implement API routes, server actions, and caching, and the event details page. I'll run git push to push it over to this branch, but of course we have to set upstream to push it over to our remote repo. Then on GitHub, you'll see that your API routes branch has recent pushes, so go ahead and create a new pull request. There's 12 files changed, and I think some of them were pretty lengthy. Everything for creating the routes to get the event details, to creating the general routes for creating new events, as well as creating the pages to display them. Let's give CodeRabbit some time to review it properly. And here's the walkthrough. In this PR, we introduced event management capabilities, including API endpoints for creating and fetching events, a dynamic event details page with data fetching and related events discovery, a booking form, image upload integration with Cloudinary, and server-side caching configuration. Here we have a more detailed per file or per cohort of files changes. Some of these are API event routes. Some are asynchronous pages that fetch the data from those APIs. And then we also have a server action that gets the similar events by slug. Here's a more detailed sequence diagram than what we've had before. A user requests the event details page. Then we fetch the event by slug from the API. And then the API talks to the database by querying the event by slug. Once the event is returned, we simply bring it back to the user. Now, on the event details page, we have a separate server action that fetches the similar events. We find them by tags, and then finally return them over to the user. There are 2 additional diagrams before. This one is interesting and is all about creating events. So from the admin side, or in this case, from our HTTP client, we can make a post request to the API events, parse the data from the form, and then upload the image to the dev event folder on Cloudinary. We get back the image URL, and finally create the event with image URL, tags, and agenda within the database. Finally, our server responds with a 201, and we have our event created. So this PR would take about 20 minutes to review. It introduces multiple new API endpoints and pages, but the logic within each is straightforward and follows consistent patterns. This is very important, not only for AI reviewing your code, but also for people that are checking it, and for ourselves later on, maybe in a couple of years, once we need to add some additional features. It's good that the code is simple to understand. Now, in this case, CodeRabbit found 9 nitpicky comments on how we can improve our code. Some of these are very simple grammar fixes, but also it found some real and tangible changes we can make to our code, such as right here. An additional piece of functionality that we can add to our application is to actually authenticate and authorize the users to be able to access this post request, which fixes a big security risk. And that is that absolutely everyone is able to create events. So naturally, some users might spam it or post some malicious content. Adding authentication to this application is definitely the next meaningful step forward. Feel free to review the other updates that CodeRabbit suggests. And then once you're done, you can go ahead and merge it. Once it is merged, back within your application, you can run git pull to pull the latest changes, and then navigate over to main by running git checkout, main, and pull the latest changes on the main branch one more time. Now that our application is looking great, and look at that, my new event also showed up, proving that the caching actually works. We can now start getting a better idea of how users are using our app. And we'll do that by integrating a couple more PostHog features. So let's do that next. Remember our PostHog dashboard from earlier? Looks like we're already starting to get some users. And you can see that this initial dashboard already has some very interesting insights, such as the page view funnel by browser, so you know how many people enter, drop off, and return. But to be able to extract more useful insights on top of just daily active users, there are some changes we have to make within our code to then be able to extract those insights. One example that comes to mind is within the book event form. This is the place where we actually make a connection from our user, or specifically this user's email, to the event itself. So for that, we'll quickly create a new server action that we can use to modify our database. Within lib actions, create a new action called booking.actions.ts. And within it, you can export a new asynchronous function called createBooking, which will accept the three things that it needs: the event ID, so we know how to update it in the database, the slug, as well as the email of the user that wants to sign up for that event. All three of these will be of a type string, so we can just define that right here, so TypeScript doesn't complain. That's going to be the event ID of a type string, slug of a type string as well, and finally the email of a type string. And now we can open up this function block. You already know that server actions are quite simple. We'll open up a try and catch block. In the catch, we will simply console.error saying that create booking failed and something went wrong, and we can return a success set to false and also the error set to error. But if we try to succeed, we can first connect to the database by saying await db connect, and then make a booking by making it equal to await booking dot create. So we're creating a new instance of a booking. First things first, make the whole create booking server action asynchronous. That's important. And also define this file as a server action files by using the use server directive at the top. Then we need to import booking right here at the top by saying import booking from @/database/booking model. Then we can create the booking with the information that we have right here: the event ID, the slug, and the email of the user who is trying to book it. Finally, we can return success set to true, and then pass over the data of the booking. And you can either stringify it before passing it over, or you can add the .lean method right here, which will return it in a basic JavaScript format, not as a MongoDB document. But to be able to call the lean method on it, you actually have to first wait for the result of that function, which means that you have to wrap this await within additional parentheses, so we can then call the lean method on it. Now we can head back over here within our handle submit, and we can call it. I'll say const, destructure nothing for now, and just call await create booking. Since we're using await, we have to turn on async right here, and we'll pass in all the necessary props, such as the event ID, the slug, and the email of our user. But right now, we don't have access to the event ID or the slug within this book event form. So how do we get access to it here? You could opt in for some kind of a global state management solution, or you can just see where the book event is getting called. In this case, it is right here within our details page. And then to it, we can just pass those two additional props, such as the event ID equal to event.id, as well as the slug equal to event.slug. We just have to be careful to make sure that the event actually has the ID, or we might need to use the underscore ID to make this work. Then you can destructure both the event ID and the slug, and these are going to be of a type event ID is of a type string, and slug is also of a type string. Now we're getting them through props, and you can see that they're properly getting passed right here, event ID and the slug. And as the result of the create booking, after we resolve the promise, we're going to get either the success or the error, depending on how it does. So we can open up an if statement and say if success, we'll set the submitted to true, and else we will simply console log the error by saying console.error, booking creation failed. And then we can render the actual error we're getting back from this function. Oh, and we have to fix it. I think we called it E, but we can actually call it error. Great. So now we're no longer just setting the timeout and preventing the default. We actually want to submit this form. And we're doing it with this simple server action. But now that brings me to the part where we want to track the number of submissions that we're getting through our application, and maybe track the behavior or the type of the users that are more likely to create that event. We'll do that through PostHog. Right after we submit, I want to capture an additional PostHog event by importing PostHog right here from PostHog.js, and then using the .capture method, which I'll call event booked. Then you can pass some additional parameters to it, such as the event ID, the slug, as well as the email. And likewise, if something goes wrong, we can also capture something, but this time it won't be an event, rather it'll be an exception. So I'll say capture exception, and I'll pass in the error. Now, if you head back over to your application, head over to one of the latest events, and if you enter your email address and click submit, and actually I think this error was here even before we submitted the form. See, when we turned on the cached components, due to the change in how Next.js handles PPR, partial pre-rendering, now every component either has to be dynamic or cached. And if it is dynamic, it has to be wrapped with suspenses, which is exactly what this error says. It says route event slug, referring to the details page. A component access data, headers, params, search params. In this case, it is params, getting the slug from the URL, or short-lived cache without a suspense boundary, nor a use cache above it. So this documentation page talks a bit more about it, but the simplest fix right now is to head over into that event details page and add the use cache. So you can now simply say use cache, and then below it, you can use the cache life, which you can import from Next Cache, and you can make it hours, same as it is on the homepage. If you do this, it'll no longer complain, because now when we submit the data or when we just visit the details page, it'll now work because it's getting the data from the cache instead of needing to re-render it. Now that we're actually firing these events, back within your PostHog dashboard, you can head over to Data Management and then Event Definitions. Here, you'll be able to see auto capture, exception, page leave, and so on. Now, if you don't see the book event that we fire from our code, this is the one I'm talking about, the event booked. To this handle submit, we can also add e.prevent default, so we can check the console just after we fire it. So back within our application, you can now enter your email once again, open up the console, and then submit it. If you do this, you'll see that we have an error within our code saying that only plain objects can be passed to client components from server components. Error objects are not supported. So I think it's pointing to this create booking thing. That might be because of this booking that we're passing here. But I just noticed that we're not even using this created booking. We're just using the success and the error. So right here, there's no need to pass over the booking once we actually create it. The only thing we care about is that it's in the database. So if you remove it from there, and if you also remove this error, so we're only passing the success of false, which should be enough for the client side to handle it. No longer do we have to get the error, but rather right here under capture exception, we can simply say booking creation failed, same as above. And when we're calling this book event, so head over to the details page where we're passing the .id. This was supposed to be the ._ID, so we get a real ID coming from a MongoDB document. Oh, and one thing that I remembered, if you head over into our server action, we're no longer even using this booking, rather we're just creating it. So we don't have to store it into a variable, and we don't have to call the lean method on it. There's just no need to do it, as the only thing we need is a boolean of success. So now if you head back to the browser, reload the page, enter your email, but make sure to use the email that you haven't used before, just in case one of our previous emails already got stored as one of the book keys for this event, clear the console, and submit it. Thank you for signing up. That's great. And you can see that PostHog just captured a new event booked. That's great. So if you head back to event definitions on PostHog and reload, you should now be able to see a new event booked custom event. So if you click on it, you can see all the properties that it pulled as an example of what this event captures. So again, in this case, it pulled up the real example, which we sent. And you can see more information about the user who we captured that actual event on. Now, to be able to track their entire session of coming across dev events in the first place and then proceeding all the way to booking, that is the perfect use case for session replays. They should be enabled as soon as you click on the button within the Quick Start Guide. There we go, right here. For me, it already went ahead and captured a couple of my sessions. It actually captured an hour-long session while I was developing the application. Oh, and alongside viewing single user sessions, you can also head over to heat maps. Heat maps allow you to explore where your users are clicking. To better see it, you can open it up in Toolbar, which is basically your application, but at the bottom, you'll also have some additional PostHog functionalities, such as the heat map open right here, where you can see exactly where your users are clicking. Looks like I've been clicking pretty randomly across the page. So if you head over to the page, you should be able to see that most users clicked the submit button, which is not really the case here, as I've been just testing the application. There's also the web vitals right here, which should be pretty good because we're using the latest version of Next.js, and most of these pages are server-side rendered and also cached, so all of our metrics should be pretty fast. And back within the PostHog's dashboard, if you head over to error tracking, remember how earlier on we turned on error tracking so we can track some errors? Well, during the process of development, there were many. I can see this reference error being repeated 5 times across 2 sessions. So if you click on it, you'll be able to see when it first happened, when it was last seen, so potentially it got fixed in the meantime, and you can define the status as either active or resolved. You get the full stack trace of the error, the properties so you know which browser or operating system your user was using, as well as the session related to that user. So if you click the recording, you'll be able to see exactly where the error happened throughout the user's process of going through the app. In this case, it might take some time to buffer since this was an hour-long session, which I honestly doubt people are going to explore dev events for an hour. But hey, here you have it. PostHog can handle even hour-long sessions. And that brings me to the end of this build. Throughout this demo course, you learned how to build a simple, yet effective and well-designed application. We went through the process of creating some API endpoints for creating different events, and we used an API client to actually submit them. Then we fetched those events right here, displayed them, and rendered the event details page. Within it, we also created another server action to fetch all the similar events. So here's where we learned a bit about server actions. Then we learned about caching this entire page, so it's not making a request to the database every single time, but rather once per hour. You learned how to integrate PostHog for data tracking and analytics. You also learned how developers nowadays use AI to their advantage through Warp. And let's not forget that throughout the process of learning Next.js, you also set up your own MongoDB Atlas database that actually keeps track of all of our events. And the code is super clean thanks to CodeRabbit, as we were able to review all of our PRs in detail, which CodeRabbit made significantly simpler with the summaries, walkthroughs, and of course, the code reviews. The only thing that's remaining is to deploy our application. So let's do that next. Let's get our app on the internet. Before we go ahead and deploy it, head over to your nextconfig.ts and type in TypeScript. Within the object of TypeScript, you can say ignore build errors and set it to true. The process of building this app was long, and it's possible that we have a little TypeScript warning here and there. We don't want those warnings to break the build, so this just saves us from that. Now, with that done, we have to push this change and all of the other changes we've made that we haven't yet pushed over to GitHub. So open your terminal, type git add dot, git commit -m, finalize the app, and then git push. Once you do that, back within your browser, head over to vercel.com and create a new project. You should be able to see that your dev events has new changes just a couple of seconds ago. So go ahead and import it. You can select your project name, such as dev events, and click deploy. We'll update our environment variables as soon as we get the production URL. Oh, looks like we have to enter a lowercase name. So that's going to be dev events. And we're deploying. Let's give it a minute and I'll be right back. Very quickly, you'll see that your build will fail. And that's because our app cannot find our base URL. So it finds undefined and breaks. That is totally expected. Head over to your projects under domains, and here you can see where your project will be deployed once the build actually succeeds. So go ahead and copy this domain name, then head over to settings, environment variables, and you have to add a next public base URL and set it equal to this URL right here. Then back within our IDE, let's grab the rest of the environment variables, everything besides the public base URL. So that is next public PostHog key and host, as well as the MongoDB and Cloudinary URLs. Then simply click add another and paste them here. Once that is done, go ahead and click save and redeploy. I remember the times when there wasn't this redeploy button right here, so you'd have to go ahead and manually remember to redeploy it. But nowadays, Vercel team makes everything so much easier. So now if you head over to deployments, you'll be able to see that your new build is, well, building, and hopefully this time it succeeds. Let's give it a moment and I'll be right back. Oh, and while the build is building, I gotta tell you a bit more about the Ultimate Next.js course. Because so far in this crash course, you've already learned a ton, from setting up analytics, databases, and AI tools, to creating APIs using server actions and optimizing performance with caching. These are the core fundamentals that every great Next.js developer needs to master. But that is just the foundation. To truly use Next.js for production-grade applications, you need to go a bit deeper. I'm talking past bad performance and actually approaching it like a powerful framework that it is. We'll deep dive into authentication with both email and password, as well as social authentication, AI integrations. We'll have custom logging functions, error handling, database integration pipelines, transactions, filters, sort queries. There's so much stuff that's happening within this Dev Overflow application, which is the star of the show. So if you're ready to take the next step, check out the Ultimate Next.js course, which more than 10,000 developers already joined and they love it. It's even used as professional training at some big companies. So if you're ready to go beyond the basics with this super detailed course curriculum, head over to jsmastery.com. If you head over there right now, you'll see that there's a special bundle going on where you can test your Next.js applications with this limited time bundle deal. With all that good talk, we are back to deployments, and I can again see that another deployment has failed. I gotta be honest, this is Next.js specific. Never before have I seen these types of errors, and I'm actually super glad that they are happening because we get a chance to go through these. And I can say this for a fact, never before seen errors, right? Because Next.js 16 is super new. It says right here that unexpected token, the deployed is not valid JSON. This isn't really giving us anything, right? Then it seems like it's pointing to the homepage. Okay, because this is the code from the homepage. But then the actual error, and it says it right here, occurred pre-rendering the page events slug. And then it points to the error message right here, pre-render error, and it says event slug uncached data was accessed outside of suspense. This delays the entire page from rendering, resulting in a slow user experience. And then they give us a link right here on the blocking route documentation page. Now, if we actually head to one of these documentation pages, specifically the uncached data was accessed outside of suspense, you can see that it is so common. It is actually listed as one of the documentation pages in the new version of Next.js. It says this error occurs when the cache components features is enabled. Yes, we enabled it in the next config. And Next.js expects a parent suspense boundary around any component that awaits data that should be accessed on every user request. The purpose of this requirement is so that the Next.js can provide a useful fallback while the data is accessed and rendered. The proper fix, of course, depends on what data you're accessing, so here are a couple of possible ways to fix it. One talks about accessing data, specifically when you use the use cache functionality right here, similar to what we are doing on our homepage and our event details page. Then if you scroll down, you'll see that it's all about the suspense, wrapping the pages with suspense so that it has something to load while the data is loading. Alternatively, you can add a suspense boundary above the component that is accessing the request headers. And here we can dive a bit deeper into the params and search param story. Layout params, page params, and search param props are promises. We know that, right? Because we are getting them right here, and we're already awaiting them. But then they continue to say that if you await them in the page component, you might be accessing these props higher than is actually required. So try passing these props to deeper components as a promise and awaiting them closer to where the actual param or search param is required. So you can see one of the changes here is once again passing them to the inner component and then wrapping the entire component with suspense. So before we continue reading to the docs, let's actually do what we just read. Back within our application, I will copy everything starting with let event all the way down to the bottom of the return statement, like this. It'll basically render the event details page empty. Like it is not returning anything, but we can just make it return like a basic div for now. The code that you copied, we're gonna move over to a new component. So create a new component in the components folder and call it event details.tsx. Within here, you can run rafce to quickly generate a new component. And then right here at the top, you can paste the code you just copied. Just make sure that this is also an asynchronous component and that you're properly closing everything so that it looks good. Then you'll also have to import all of the additional components, such as the event detail item, event agenda, and event tags. So I'll get those from the page. This page should not be concerned with handling those. We'll just copy them alongside the base URL and use them right here within the event details component, not the event details page. There we go. Now everything is here. Then this component will be destructuring the params. Similar to what we've done before, that'll be params of a type promise that resolves in a string, like this. Then here, we'll also move the caching mechanism. Use cache, cache life, and const slug, basically rendering the event details page completely empty for now. Make sure to import cache life from next cache, and then slug will be directly coming from the params this time. So what we've done now is we have extracted all the logic and presentation from the event details page into the event details component. Now we can head back over to the event details page, and I'll completely clear it up of all of the imports that we no longer need. You can see now it's a very simple page, and I guess that's the point of Next.js. That's what they want to achieve. They want to make it so that page is now a static shell that wraps around dynamic content. Let me explain what I mean in code because it's super confusing. Within here, we're again destructuring the params that are of a type promise, which result in a string. But now we'll get to that slug a bit differently. For this, we can refer once again to the docs. Check this out. It looks super weird, I'm not gonna lie. Before, we were just able to await the params and just feed them into the whatever function we wanted. But now what you have to do is get them like what we have done in the previous component, right? Into its own component. For us, that was the event details. But then within the actual page, you have to add the search params dot then, and then get them like that. Super confusing, but let's follow what they say. Within here, these are params, so we can say const slug is equal to params dot then. Then we get an individual, I guess we can call it param or p, and then we return the p.slug. Okay. Then within here, we'll return a main div as we're returning a page. Within it, I'll render a suspense. This is a component coming from React, which allows us to display a fallback while the inner contents are loading. So I'll say fallback is equal to, and I'll set it just to be equal to a div that says loading, like this. While things are loading, we can start to render the event details component. This one right here, coming from components, event details. And as params, we can pass the slug. So now that our component, which is caching the data, is wrapped within suspense, we should be good. And now just before we retry the deployment, I want to head over to our homepage for a second and see here that our base URL on localhost is pointing to localhost, but we have already updated it to the final deployed URL within environment variables on Vercel. But the app never actually deployed, so it'll not be able to make a fetch request to API events. For that reason, what we can do is make another push that is just going to result in a successful deployment by commenting out the response and events, and then importing events coming from lib constants. That way, we're going to render the fake events for now, but then once the URL is deployed, we'll be able to uncomment this and do another push. So with all of these changes implemented, according to Next.js 16 docs, we can now run git add dot git commit -m. I'll say comply with v16 gods and git push. Now, if you head back over to your deployments, you'll be able to see that a new deployment is queued, or for you, maybe it already started building. And there we go, it deployed. So now if you head over to the overview, you'll see, if you click visit, that we're online with our 6 fake events. So now that we're actually online, we can use this URL within the environment variables to load real events from the database. The only thing we have to do is uncomment these 2 lines, remove the fake events, and make another push. So run git add dot git commit load real events and push. This will re-trigger the deployment, but this time with real events. And would you look at that? It looks like it succeeded again. So if you again head over to visit this page, this time it loads real events. And here you can see the suspense as it's loading the event for the first time. There we go, the event description loaded, but you might have seen that it took a bit of time to actually load the page. Sure, you could add a better suspense with some skeletons, loaders, and so on. That's exactly what we do in the Dev Overflow course. But still, it felt a bit too slow regardless. So here's one pro tip. Head over to MongoDB Atlas, head over to your project and then clusters. And under clusters, you can see the region of your cluster. That is where your database is hosted. You most likely chose the version that is closest to you, whether it's Frankfurt for Europe or something else for the US. What matters here is that whichever region you chose is also the same region or a very close region to the region where your website is uploaded. So on Vercel, head over to settings, type region right here, and then go to function regions, you can see here it's using North America for me, whereas for my MongoDB Atlas, I think I chose Frankfurt. So I'll just turn it on. I think you can turn on up to 4 different regions. And then you will have to redeploy one more time. And then when you switch between pages or load some data, your server will make a request to the database much quicker because they're going to be much closer together physically. So let's wait until it deploys and we can check it out. And there we go. The redeployment is out. So if you visit it once again, oh, that felt much faster. And if I click right here, it loads a bit faster, and we can also check out some other pages. And the next time you visit them, it should be almost instantaneous. Keep in mind that this is now cached, so even if you make some changes to it, you won't be able to see new events for about an hour, which is totally okay because this is the type of websites that people don't expect the real-time updates on. Rather, we want to make it efficient and want to make it load fast, which is the whole point of this caching rehaul in Next.js 16. But of course, that's the topic that requires a much deeper deep dive than this. So as soon as I press stop from recording this video, I'm moving over to adding additional modules to the updated Ultimate Next.js 16 course, where there's going to be a whole new module on just caching added to our Dev Overflow application. With that in mind, thank you so much for coming to the end of this video. If you liked it, you'll enjoy the Ultimate Next.js course. It allowed me to go into that much more depth. So if you decide to join, welcome. And if not, I'll see you in the next video. Have a great day.